let me give you my introduction. My name is Satyam Govila, and I will be your instructor for this MySQL course. And basically, in this course, we are going to study from the very basics about all the MySQL concepts and all of the data concepts, like how they are stored, how they are queried, and how does data works in the production, like when you will be working with the real data, with the industry data. And we will be learning a lot of tools and technologies related to this. And also we have dedicated 2 to 3 separate lectures for this interview preparation. So this interview preparation will be very rigorous, like most of the questions starting from basic till advanced will be covered there. And I will be teaching you the way, like how the questions are asked, what is the format, and how can you basically develop your approach and think in that direction to solve those MySQL questions. And also, I hope most of you are also well versed with Python as well. So we will be also covering few of the Python interview questions as well. So in for that also, I'll try to develop your understanding and your approach, like how to solve those questions and all. That was pretty much about me and this course. Before learning about different tools and technologies and about SQL language, okay, let's first understand most of the concepts about data. Okay, so data is a very hot term going today, because almost all of the companies in today's time are relying only on data. Data is basically the base of your product. Like all the companies are basically relying on data tools, like how to store, how to process, and how to get insights from it. So data proves to be a very integral part of any company's foundation. So like as it is written here, that everything that we do is generating data. From browsing internet to ATM cash withdrawal, you must be surfing your internet, right? Or you must be watching some videos, streaming devices, or let's say you are doing some financial transaction. Let's say you are withdrawing money from ATM, or you are transferring some amount, or maybe let's say you are browsing some e-commerce website like Amazon or Flipkart or anything. Okay, so there also you can see that how much data is involved. So everything that we are doing is basically relying on data itself. Okay, so data is actually everything, and data is everywhere present. So like here it is written, just an example, that for an e-commerce application, products, users, and the purchase, all things in are the data. So let's study about this point, this example. If we talk about you must be comfortable with MS Excel, right? So let's say in Excel we can store only limited amount of data. Okay, but still, let's just take an example of MS Excel only. If you were to create few MS Excel files for Amazon, so how many different type of files you can create? So for example, there can be one file that can be for customer information, like how many customers logged in, what is the name, address, phone number, postal code, country of different customers, right? So that can be one file. One example I gave you, yes, product. Okay, so basically you can create product catalog information. Okay, so basically you can create the all the products listed there. So basically you can create a Excel for that. We can create some orders, right? We can create one file for the financial transaction, that is like what was the amount of order and all. And let's say maybe we can create if the order was successful, so successful orders or cancelled orders, or maybe the refund orders. Okay, so there are a lot of Excel files which you can create. So in other terms, if we go a bit deeper, so we can say that there are a lot of tables in MS Excel. We have tables. So we can say that if we take an example of e-commerce application like Amazon, so there are a lot of tables that we can create. So depending upon your data, depending upon the type of information that you would like to store, we can create many number of tables. So if you have such large amount of data, and if you are going to create a lot of tables, so you need a proper framework in which you can create and store those tables as well. You need a software which can basically deals with these large amount of table. So that system, that architecture is known as DBMS, that is database management software. So in these type of architectures like DBMS, what you can do, there are n number of things you can do. So basically, first you create databases. Databases are basically used for storing the tables, just like MS Excel. MS Excel has tables. So in databases, you can basically store tables. As I was talking about database management system, so database management system can help you to create databases. Databases has tables stored in it, and inside tables, what do we have? The actual records, the actual rows of data. So to deal with this large amount of data and large amount of tables, and to query this data also, when you have stored this data, you also need to query also. You can basically query your data to get customers information, or to get any products information, or to get any kind of information, or to just get the general statistics, like what are the total number of users, or what is the maximum amount placed by any user, and so on and so forth. So there are n number of operations which we will be learning about. So basically you need to query your data also. So for that query purpose also, your database management system is necessary. So querying your data means basically searching, like writing some queries and get some useful insights from the data. Either you can modify the data, you can update the data, or basically you can add the data, or you can search for information within a data. So that is a part of the query which you will be writing. If we talk about storing the data, okay, so depending upon the amount of data you are dealing with, so you can store your data into these three different types. Okay, so first is your RAM, the RAM which you have in your computers. Okay, so a very little amount of data can be stored in that memory. So that is a very little data that we are talking about. So if the data size is increased, so that data can be stored in flat files, stored in the file system. So file system, I think you all must be aware of. Like if you are using Windows, so you have your C drive, D drive. Okay, that is your file system basically, the file system of your computer, the hard disk. But what are flat files? So flat files are your files in which you actually store your data. So like Excel files or text files or CSV files. Those are basically generically known as the flat files. So you can store your data there also in MS Excels. Just for a clean example, so you can store your data in MS Excel files. But now if your data gets huge and there are a lot of operations involved, then that data is basically actually stored in your databases. So that's a general idea behind like how and where you can store your data. Let's understand about database management system, that is DBMS. So DBMS is a software for storing and retrieving users' data while considering appropriate security measures. It consists of a group of programs which manipulate the database. So, what do we mean by this? So, DBMS, as I told you, it is a software, okay, for storing and retrieving the data. So, basically, you can store your data, any kind of data, and also you can query that data. You can retrieve that data while considering appropriate security measures. So what security measures are we talking about? So see, this data is very, very important as far as security is concerned. Let me take an example. If you are working for a banking firm, and if by any case the data gets leaked, so it will incur huge losses to the banking firm. So that is why data security is very important. Like how much data to show and to which users should have access and for how much time, and users should have access to which tables, which databases. All these things are covered under security measures. So DBMS handles that also. So not only storing and retrieving data, it also takes care of who is checking the data and what operation is he doing. It consists of a group of programs which manipulate the database. So basically the programs, the language, all this you will be studying in later sessions. So it will help you to manipulate the database. Now the DBMS accepts the request for data from an application and instructs the operating system to provide the specific data. So what does this mean? Let's say you have an Amazon application. Okay. Now behind Amazon application, there will be a DBMS server. Behind any kind of application, there will be a DBMS server. So your application will post a request to DBMS, and DBMS will in return will give you the information you requested for. So in large systems, a DBMS helps users and other third-party software to store and retrieve the data. Now, the third point is DBMS allows users to create their own databases as per their requirement. The term DBMS includes the user of the database and the other application programs. It provides an interface between the data and software application. So when it is written here that DBMS allows users to create their own databases, so it means that since like I gave you an example of e-commerce application, so depending upon your use case and depending upon your need, depending upon your requirement, you can create different kinds of databases. So let's say one database we dedicate only for orders, one database we can dedicate only for customer information, there can be one database which is only for the financial transactions. So depending upon your use case, you can create your own database, and inside that you can create your own tables also. So all of these operations, like whether creating the database, storing or retrieving the data, or control the access, like who can access which table and up to how much extent, all these things are covered under DBMS, that is database management systems. As I just told you, that in DBMS we can basically control the user's access. So we can basically create few roles, we can create the users, and we can check that who is logged in and who is not logged in, and we can basically control to which database he or she has access. And also we can basically control that if the person who has the access, like what access does he have? Does he have only the read operation, or he can also write something on the table, that is using some delete command or update command, or maybe any other information. So we can basically control all of it. So if we talk about this MySQL software, MySQL tool, so it has the functionality to do all of these things. So why should we learn DBMS? Okay, so like understanding the DBMS and the concept is fine, but why are we actually learning it? What is the need? So the first point is, without understanding how the data is dealt in a system, we can't really understand any product. Okay, so let's say if you want to understand like the functioning of the system, like how the organization is working or how any project is working, first you need to learn that how the data is being dealt, like how the data is being stored, how the data is being accessed, and what is the flow of data, like how are you processing the data. So those things need to be understood first, and then only you can understand the proper functioning of the software. The main role of developers, testers, automation guys is to add value to the product, and without proper understanding of DBMS, a product can't be really understood. So if you want to understand a company's product, then you need to understand the data that is underlying beneath it. So that is why it is very important to learn about DBMS. So here we have a 3-tier architecture. That is, we have a client server model. Okay, it's not a very complex architecture. So there is a client, we have a server, and we have a database. So client is basically your application, any application which you are using, any application in your mobile phone or any website, anything. So what happens is this client basically posts a request. That request can be, let's say, give me the information of these 10 users, or give me the information of the 10 customers in this city. So this can be a basic request. So the request will go through the server, and will go to the database. The database will query the results, query the data, and will return the results through the server again back to the application. So this is the basic architecture of DBMS. There is a query, you query your data, and you get back the response. And if there are multiple queries, if there are multiple requests, then those multiple requests are handled by the server so that there is no downtime. Now, this was mainly about this DBMS. So now there are basically two types of databases. So first is your RDBMS and second is your NoSQL database. This MySQL and MongoDB are the examples. This MySQL software is the example of RDBMS and MongoDB is example of NoSQL. So first let's check out what is RDBMS and what is NoSQL with the help of example. So let's take the example of the data that we are going to deal with. If we talk about any MS Excel table, so let's say we are storing some school data there. What kind of data can we store there? Like the information of all the students, what is their name, roll number, their ID, their first name, last name, phone number, and maybe address, marks. So all that information can be stored in a table. Can we be sure, 100% sure, that all the students will be having all the information about all the fields? So let's say we can say that yes, every student will be having the first name, he'll be having the address, he or she will be having the marks. So in that case, we are basically creating a single table or multiple tables, doesn't matter. And in those tables, we are basically storing the information in all the fields. So that is an example of a relational database management system. Relational means a table. So that means the data is stored in the tabular form. And in this series of lectures, we are going to deal with RDBMS only. Okay, that is relational database management system, in which we will be having the data, we will be having a lot of fields, and mostly all of the fields will be filled. So this is an example of RDBMS type of databases. Relational database management system is clear. So you are going to study about RDBMS mainly. Next, we have this NoSQL database also. Now, let me give you the example of this NoSQL database. So let's say you are dealing with the weather data, the climate and the weather data. So let's say you have a device which on, let's say, Monday reported the data about the weather forecast, about the weather information in 5 fields. That is, what is the precipitation, what is the humidity, what is the temperature in Celsius, and will it rain or not, and so on and so forth. But there might be a case that on Tuesday we are getting more than 5 fields. So let's say we are getting the information, more information about rainfall only, like in centimeters, how much did it rain, or any other information. So there can be a varied amount of fields on every day. And let's say on one day, if it is a sunny day, so there might be information that no rainfall is recorded. There can be varied types of information receiving on a daily basis. So in that case, when we are having such amount of information in which we can have a lot of fields empty, so in that case, we are dealing with a different type of architecture, that is NoSQL database. So one example of this NoSQL database is MongoDB. Let's learn about the specific type of DBMS that we are going to cover throughout the session, throughout the series of lectures, that is MySQL. So we have chosen MySQL as a primary tool to work on. And in this MySQL tool, we will be learning about basically how to install it, how to configure it, and then how to run different queries on it. Now, I will be telling you the installation steps. To install MySQL on Windows, you need to go to the following URL. So the basic screenshots are already given in this slide for your ease, but I'll still show you. So this is basically your, this is where you have to go. So this is the basic installer which you need to download. That is the community installer. You need to install the community installer, and you need to download here this community installer. You don't need to install this web community version. You need to install the community version. So you can go to this link and download. Now let me show you the steps to download, install, and configure. So when you will click on this download button, and in this, you don't need to create your account.
Okay, you don't need to create your Oracle account or anything. Just simply click here, no thanks, just start my download, and it will basically start downloading your file. Okay, and then we will install it. So once you have downloaded your file, okay, just double click on it to install it. Okay, and now we will learn how to configure it. So for installation, you have a couple of steps here. We have this developer, server, client, full install, and this custom install. Okay, so since you will be covering almost all of the configurations, so you need to do a full install on it. So just click on full install, click on the next button. Now here it will list down the tools that will be downloaded. So here it, as it is written here, MySQL for Excel, so it will be downloaded. And in few cases, with few of the past students, we have observed that those who had Visual Studio already installed on their systems, so they faced some problems while installing and configuring. So if you are having Visual Studio already installed, so it will be a good practice if you can uninstall it. So there can be a problem otherwise. So if you don't have Visual Studio, no problem. But if you have, then maybe you can uninstall it. So as you can also see here, I don't know if this part is visible or not. Here in requirement, it is written here that Visual Studio 2010 tools for office runtime is not installed. So in this system, already this was not installed, so it will be installing. Here it is in the requirement. So there is sometimes the compatibility issue. So that is why sometimes you are not able to properly use MySQL. So it's just a suggestion. Rest is up to you. You can uninstall it and then you can install MySQL. Now, the next step is, so you can see the following products will be installed. So MySQL Server, MySQL Workbench, Notifier, MySQL for Visual Studio, different connectors, a basic documentation file, and all of these things, they will be installed along your installation. Now you need to click on the execute button. Okay, and you need to wait for a while before all the components gets installed. So it will be installed, and then you need to configure all of these. So here it is going to configure server, router. Okay, so these will be configured. Now this is important. On this availability, you need to choose the standalone MySQL server. You don't need to go for this InnoDB cluster. Okay, that's something very high level and you don't need to go there. So you need to click on standalone MySQL server for your MySQL software. Now click on the next button. Here you need to use your TCP IP protocol. The port number is already mentioned here. So you can just use this 3306 and just click on the next button. No specific differences. Now use strong password encryption for authentication. This is the recommended one. Just click on next. Now this is the most important part in which many students makes mistake. The password which you are going to set up here and the username also will be used multiple times going forward. Not only during the installation, but when you are running MySQL queries also. So please don't forget it. Write it somewhere in your mobile phone or in your computers or in your notepad, anywhere. Don't forget it. Otherwise, there is no potential effective way in which you can recover it. You need to go to step one, uninstall everything and do a fresh install if you forgot it. So please choose a easy password for now and write that password somewhere. Don't forget this MySQL root password. This is very, very important. So set up a easy to learn password. Just confirm your password, click on the add user button and add your user with the admin role, and that's enough. Now here again, write the username and password, choose the role as DB admin. That is, you will be the database admin for your system, and write down your user credentials, the password which you just set up, and click on the OK button. Now you can see that your password is set and the admin which you have created is also set and the role is also set. Okay, so your username will be admin and your role will be that you will be the administrator. Now click on the next button and here you don't have to do anything. Okay, just click on next. It's a basic configuration. You don't have to do anything here also. Just click on execute button, wait for some time and it will be configured. Now just click on finish button. Here also you don't have to do anything. Click on next button. Here just write down the previous setup admin and password, the password which you already set up. You have to enter here when you are connecting to the server. So you have to enter this username and password, the password which you already set. just right here, click on the check button. Here, if your connection is successful, if you wrote the ID password right, then it will show here connection succeeded in the status. Just click on execute button. Just click on next. There is nothing you have to do here. Okay. And then finish. Okay. So in this way, you have to basically install your MySQL. So the process is very simple. Okay. There is no much tedious part here. It's just that the most important is try to do a fresh install, try to remove VS Code if present, and don't ever forget your username and password. Now, after this installation, okay, just type MySQL in your search bar and you will get this MySQL command line client. Okay, MySQL command line client. So basically this is where I will be working on. Okay, so just click on it. A terminal will open and there this will be a black screen, and all of the queries which I'm going to teach you, I will be practicing here only. So here first it asks your password, the password which you already created during the installation. You need to enter it here. Although it will be one time only, but there can be few cases like after few days or after running few queries that it might ask your password again. Or if you are reinitiating your software, relaunching your application, then it will ask you. So just remember your password.
So this will be the screen which will be shown to you after you have done the successful installation, configured it, and have entered the password there. Now, this is your MySQL software. This is your MySQL UI, the basic black screen, and we will be running the commands here. We will be studying about like how things are going there. We have this databases. We have this DBMS software, DBMS. So for example, we are taking MySQL. Okay, we are taking MySQL. Now, what will we have inside our databases? We will have, let's say we choose 1 DB, that is database. Okay, now what will be present inside my database? We will have different types of tables. Clear? We will have different type of tables, and that table will be structured. That table will have structured data. What is structured data? Having proper rows and columns. Okay, and inside this table we will be having the data, the actual data. Okay, in rows and columns, rows and columns. So we have a DBMS. We took MySQL for example. Then we select one database. Inside the database we have different tables, and in that table we have data in the form of rows and columns. That is the structured data. Let's say you took one DBMS. So the example is given in the parentheses. Okay, so that will be MySQL. Now, what is present inside? Let's say you have, let's say your use cases. Let's say your use case is e-commerce application. So inside your database, let's say you have three databases. So there can be one database of which has this user information. So it can be user DB, there can be a orders DB, and there can be a finance DB, depending upon your use case. Now, if we select any one particular database, let's say orders database. So here we can have three tables. I'm just taking an example. So one table can be all those orders which were completed orders table. Then there will be all those orders which got cancelled. That is the cancelled orders. And finally, we can have one table for refund orders, that all those orders which need a refund. So the flow is like this. Similarly, we have this user DB also. Here we can have multiple tables, and similarly we can have finance DB. Okay. So where you are actually going to store the data, you are going to store your data inside the tables. So now let's go back to my terminal. Okay, coming back to my question, what was the first step? The databases. So the command is very simple. That is, we need to check out what are the databases that we already have. Okay, so the command is show databases. show databases. And MySQL, the best part is that it is case insensitive. Whether you write in lowercase or uppercase doesn't matter. SQL is case insensitive, so you can write in uppercase or lowercase, it doesn't matter at all. So now every statement terminates with a semicolon. So there are two things which we learned here. The first thing is that you can either write your queries in uppercase or lowercase, it doesn't matter at all. And the second thing is all the queries terminate with semicolon. So if I run here, show databases, so you can see the couple of databases I have already. So I previously installed it in my system. So these are the couple of databases. So when you will do a fresh install, so I think information schema, MySQL, performance schema, and sys, these databases will come by default. And then you can create some databases on top of it. So this e-commerce DB and this EdYoda DB I created, and all of these 4 DBs came by default. If I need to select any one particular database, there is a command that is use. Okay, that is use. So let's say I am writing EdYoda DB. Okay, so I selected this database. So to select this database, I'm using the command use EdYoda DB. Okay, so here if it is successful, it will show you database changed. Okay, so now you are inside this EdYoda DB. What is present inside my database? Tables. Okay, so the command will be same. You will run show tables. Previously it was show databases, now it is show tables. So here these are the couple of tables which I created in the past. Okay, so you can see the list of all of the tables. If I have to read the data from any of the table, so I will be writing the basic command. This command will be carried forward throughout the series. The command is very simple. The command is select star from, let's say I'm checking out the bonus table. There is a bonus table, and then I will eliminate with semicolon. So let me just run it and then I'll explain you the command. So the command is like this: select star from bonus, and then we got this table. So you can see that this is the structured table. You have the proper columns, proper fields, and you have the proper rows. So here we have the information of workers. We have the reference IDs of all those workers, and we have the bonus amount and the received bonus date, the date on which they receive the bonus. Okay, let me just highlight it. Select keyword. So select keyword is basically selecting all the columns. I'm repeating myself. Select keyword is to select the columns and not the rows. Select keyword is used to select the complete column and not only the rows. Star means all. That means selecting all the columns from this table. I can write it like this: select star from bonus. All is it lowercase. Okay, doesn't matter at all. Okay, so I'm repeating myself. Select means selecting the complete column. Star means all, and from table name. Semicolon is mandatory, otherwise your command will not get executed. Let me show you. Let's say if I'm eliminating the semicolon and I'm just pressing enter, so it will just go into the next line. It is expecting some more command. So when I write here semicolon, then only it will execute. Now there is one very important point which I would like to cover it. I told you about the select keyword. Select keyword is selecting the complete column. Let me explain you about the star. Star means all. Okay, selecting all the columns from bonus. Let's say I want only 2 columns from here. Let's say only worker reference ID and bonus date. In that case, my command will look like this: select worker reference ID, comma, and then bonus date. I'm just copy pasting it from my bonus table. Okay, then I will get only these 2 columns, but these 2 complete columns. If I write like this, select worker reference ID from bonus table, I will get only worker reference ID. So that is the basic meaning of select and star. So when you are writing select, you are telling that, okay, I just want the complete column. When you are writing star, that means you are writing all the columns. So let's start the session. Now let's first see how can you create your own database for your personal use. So the command is like this. And the best part about the SQL language is that most of the commands are very similar. So whether it is like creating a database or whether let's say it's creating a table, so mostly it's similar. So you don't have to learn very extra things. So the command to create a new database is create database, and then you need to provide the database name in front of it. So let's say we can give any database name, people info db, people info db, any database name you can give, and now a semicolon. A semicolon is necessary to terminate a statement. So let me run this. Now it says, let's read what is the output. It says query okay. That means our query has run successfully. It says one row affected. That means one row has been added. And then it gives time 0.04 seconds. So what is this time? This time is basically the time of execution of my query, that my query took 0.04 seconds. So going forward, like after a while, like after 8 9 sessions, you will come to know that why this time of execution is important. I can just give you a hint right now, because let's say you are working in a company, and someone asks you to query the data. So if your query is not optimized, so you will return your data in 1 2 minutes, but that is not fine, right? You need to return the data as soon as possible. Have you seen Google? When you Google, there also it shows that in how much time it returned the output. So that means the time of execution is very important here. Okay. So let's say if your query is not optimized, let's say you are writing a query which is very slow. So you need to optimize it also. So that is why keeping track of time of execution is important. It will be very beneficial when you will be working with the actual real-time data set, a real data set in a company. When I run this command again, show databases, let me just see. So here you can see that my newly created database will be present here. Create command. So just a heads up that this create command is used to create a database and is also used to create the table also. Both with the create command, you can create the database as well as the table. What is the next step? How can I use this DB? Like what should be my command to? It should be use. Okay. For database, you just need to write the command use and then the database name. So you can see it has written database changed. Now, how to check what are the tables present inside it? The command should be show tables. So here it is showing empty set because right now my database is empty. So we need to create a table here. We need to create a table here, and let's see how can we create a table. So just for clarity and readability, let me show you on one editor, okay, so that it's just more readable. So let me show you in the editor, then I will run the command. I'll just copy paste it on the terminal, doesn't matter. Okay, okay. Creating the table in SQL. Okay, so the command is simple. It's create table command. Just like we have create database, here we have create table. Okay, now let's say in this we need to create a table, and the table name is, let's say, people table. Okay, people table. What is present inside my table? Columns. So we need to mention the columns. So there are a few things which are important in a column. Okay, first is what is the column name, and the second is what is the column data type, like whether the column is of integers or whether it is decimal or whether it is a string value or whether it is a boolean. These all are data types. So now let's create a data type, columns in my table. Let's say a few columns are there, so let's add. Let's say first we have id. Okay, or let's say not people, let's say person. Let's keep the table name short, persons. Okay, now let's say we have a id, and let's say the data type of this column is integer. Now let's say we have name. So here in MySQL we have many types of data types. Depending upon our use case, we can use it, but for now, since we are in the initial stage, I will be teaching you only two of them, the very basic ones, and then we will build upon them. So the second one is varchar. Varchar. So varchar is basically, as the name suggests, variable characters.
So here you need to specify the size also. So size can be ranging from, let's say, 0 or 1 to 255. So here the maximum range can be 255. So let's say I provide the maximum name, a maximum range. I provide here ID, name, varchar. Now let's provide address also. Address will be too big. Let's provide city, and city will be varchar. Again, let's keep it 255 for simplicity. So this will be your basic command to create a table. So here the command is very simple. Just like you have create database, similarly you have create table, and then you need to provide the table name, and then our table has the following 3 columns. Okay, now let me just run this command. Okay, now I've just copy pasted here and I'm running it. So it says query okay, 0 rows affected, and time of execution 0.08 seconds. That is fine. My query is okay. That means it ran successfully. If there was some error, it would have shown me syntax error or something. So since I'm already in my people info DB, I have created a table. Now let me just check and run this command, show tables. So it will show me my newly created table. So for this integer data type, let me just write it down here. So if you have the integer data type, so integer data type will be used store numbers only. Okay, and let's say if we talk about this varchar, in which in bracket, let's say we write the size, so it can store variable characters with maximum length of x. Okay, don't worry about it. So there are basically 2 types of data types in this, char and varchar. So char is basically your fixed size and varchar is basically your variable size. So when I will be showing you the different data types, then I will show you the exact meaning. You can create your own table. Okay, this is a very simple table, and in this way you can create it. Now let's see how can we insert the data here. So here, if you can see, let's say if I run this command, select star from persons. Persons is my table name, right? So here it is showing empty set. Okay, here it is showing empty set because this is a newly created table. Now let's check out how can we insert the data. So there are 2 methods to insert the data. There are 2 methods. So the first method is, the command is same, just the method is different. Okay, so let's say there are 5 columns in your table. So the command will be insert into, okay, insert into the table name, and then you need to provide the column names of all the columns. So let's say if there are 5 columns, you need to provide the column names, column 1, column 2, column 3, column 4, column 5, and then you need to write values, and inside you need to write the values. So this is method 1. I will also show you while running it. The second method is, let's say if you don't need to mention the columns, let's say there are 20-30 columns and you don't want to mention all of them. Okay, you don't want to mention all of them, so you can skip writing this part and instead you can write the values like this. So what is the basic difference between them? So if you are writing all the values, if you are providing all the values, then you don't need to write the column names. But let's say if you're providing only 2-3 values, then you need to specify column names. The significance of mentioning it like this is only this, that value 1 corresponds to column 1, value 2 corresponds to column 2 in the order in which you are providing. And similarly, value 5 corresponds to column 5. So let's say if you want to, out of 5 columns, you want to provide values for only 2 columns. Okay, so just write down column 1, column 2, and write down here values, value 1, value 2. But if you are mentioning all the values from value 1 to value 5, then you don't need to provide column names. I'll show you the demonstration of it, and then we can see if you are able to understand or not. So let's come back to our screen. Now here we had, I think, 3 columns. We have ID, name, and city. Yes, ID, name, and city. Okay. So let's insert the values. So first we'll try our method 1. So the command is same, insert into, and then my table. So it will be persons, insert into persons. Now, let's say first I'm referring to my method 1. So let's provide all the column names here. So what are my column names? ID, name, and city. ID, name, and city. Now let's write values, whatever are my values. So let's say ID is my 101. Okay, any ID I can give, and name. So yeah, before I progress, when you are writing the integer value, you don't need to provide any codes. But when you are providing any string value, you need to provide single quotes. So let's say the name I'm providing, let's say Aman, any name I'm providing here. Let's say Aman Kumar, full name I can give here. Okay. And let's say it asks for city. So let's say Delhi. Now, when I run this, so it says query okay, one row affected. That means one row has been added. Let me read my table. So select star from persons. So you can see my table has been created and my first record has been added here. Now let's do a slight modification of this as well. Okay. Let's say I write like this. Values. Okay. Let's try inserting one more record. 102. Let's say run. And let's say the city is, let's say Noida. Now let's add multiple records, okay, at the same time. So what I can do, just write a comma and again write values 103, and let's say we can add a new name. Let's say Manan Kumar, any random name I'm giving here, and let's say the city is again Noida. And I just wrote a wrong command by mistake. You don't need to write values again and again. You just need to provide values and then just comma separated parentheses. Okay. So here you can write 103 and then Manan Gupta, just random names. And let's say again it's Noida. So I just forgot it. So you don't have to write values again and again. Just write the semicolon, and since I run it, it says query okay, 2 rows affected, records 2, duplicate 0, warning 0. That is fine. Let's read my table again. Select star from persons. So it is giving me my 2 records which were inserted at the same time. So in this way, you can insert single record and you can insert multiple records as well. Now let's see one more modification of it. Okay, let's say I write here insert into persons. Now just notice that I'm not going to mention the column names. So in which case can we avoid writing the column names? If we are going to enter the values in all the columns. So you can simply write like this, insert into persons and then values. So what will be my values? Let's say 104. Let's say my name is Pratik. Let's avoid the same name. And let's say the city is Gurugram. Now here, since I'm writing all of the values, so I don't need to write any column names. So it will work fine. Now let's do one more modification. Let's say I was inserting one record, but I deliberately skipped this. Let's see what will happen. So it says column count doesn't match value count. Okay, so these are my values, right? So how many values I'm trying to insert? 2. Okay, and how many columns are there? 3. So that is why it is saying that column count doesn't match value count. So in that case, when you want to insert less number of values as compared to the number of columns, then you can't write it like this way. So instead, what should you do? You should use the previous method, that is use the column names. So you will do it like this, insert into persons. And now let's say I provide only ID and the name, and then I provide values. Okay. So let's say my values will be 105 and let's say name is Ram. Okay. So now I'm able to insert the record. So let me just repeat it again. When you are able to insert, when you want to insert all the values, you don't need to provide this column names. But when you want to insert only specific values, then you need to provide the column names. So when you read this table, select star from persons, it will show you the city as null. In the later sessions, I will teach you that you can update your existing records. the records which are already present in your table, you can update them using the update keyword. Okay, but that I'll teach you later on. Okay, so basically you can modify this value also. Query okay means query is successful. One row affected means one row has been added into our table, and this means time of execution. So let me just repeat it from the start. Okay, so if you want to insert, let me just take the same example. If you want to insert the records and you know that you are going to insert in all of the columns, you don't need to provide the column names. But if you are going to provide only into specific columns, then you need to provide the column names. It's pretty much obvious. There's nothing very complex about it. So in this way, you can insert your records. So basically, what are the things that we have learned up till now? How to create a database, how to create a table, how to insert a record, how to insert multiple records, and what are the two methods to insert the records. So this was all about inserting the records into our table. Now, let's say if you want to select any particular column, that is why the select is used. So you can write either select star, or you can write like this. Let's say select id comma name. Let's say you only want id comma name, so you can write like this from persons. And if you write like this, select name comma id from persons, then your order will change. Okay, so depending upon your order, you can mention in the select clause. Now let's learn one new topic. Now I told you that select command is used to select the whole column. So that was column based. Now what if I want to filter out my rows? What if I want to filter out my rows? So let me show you. So this is my table. Now let's say I want to get the details of only ID 102. That means now I'm filtering out my records based on my condition. Then there is something which is known as the where clause. That means the where condition. So let me show you. All you have to do is select star from persons, and then you need to write the where condition, where clause. So my where clause is id is equal to 102 and semicolon. So when I run this, I will get my single record, that is 102. So this is my where clause in which I have provided the condition that my ID should be equal to 102. So this is basically my where condition. Now let's say I write like this, where name is equal to Pratik. Okay, this query won't work because of the single quotes are missing. Okay, so you can see unknown column name Pratik in where clause because this is the string value. I told you that whenever you are using the string value, you need to provide the single quotes. So now when you provide here single quotes, now it should work as expected. So please don't forget this point, that when you are writing integer, quotes doesn't matter. But when you are writing the string value, the quotes are mandatory, whether inserting the records or whether reading the records. Let's say if I write like this, where city is equal to Noida. Okay. So when I run this command, it basically matches all the records having the city Noida. So it gave me multiple records. It's not that we will get only single record or the first come first basis. No, it will select all the records having the city Noida. Now, if I write like this, let me show you the data first. Okay. Now, if I write like this, where name is equal to, in single quotes, Aman. So will this query work or not? Also give the reasoning behind your answer. So the answer is that this query won't throw any error, but will not give the desired output. Why? Because within the single quotes, exact name should match. So the answer is yes, query will run. It won't throw any error. It's just that the name is not matching. So you need to provide the exact name with spaces. So let's say if I provide any random name, let's say like this, the query is still executing, but the results are empty. Now, let me just give you one last example in this where clause, and then we will go to our slide. So let's read the data, select star from persons. Let's say, let me insert one new record. So I write here insert into persons, ID, name, and city. Now I write here values, and my values will be, let's say, 106, and name I can give as Pratik, and let's say the city is Hyderabad. So now, okay, we have two records with the name Pratik. So when I write here where name is equal to Pratik, I will get two records. Now, what if I want to filter out my records? What if I want to provide my city also? I want to say that my name should be Pratik and city should be Hyderabad. You need to provide both the conditions in the where clause. So in where clause, you can provide multiple conditions also. Okay. So this we are talking about operators, which I will teach you in detail after a while. But right now, I just want to give you a hands-on session so that you can understand it more clearly when we will be learning the slides. So what you can do it like this is where name is equal to Pratik, and then you will use the operator. Operator, I will use and operator. So if I write here where name is equal to Pratik and city is equal to Hyderabad. Okay. So it will make sure this AND operator that both of my conditions are true, then only it will return the records. So it is checking that, okay, name is Pratik and city is Hyderabad, then only it will return the record. If by any chance, let's say I provide here any, let's say Noida, then it will give me empty result. Because why? Both the conditions are not matching. So to return the accurate records with the AND condition, both the conditions should be true. Now let me just show you one more operator and then we will go to our slide. So if I write here or where name is equal to Pratik or city is equal to Noida. So what will happen? It will give me these four records because or condition means that any one of the conditions can be true. So in the first condition, city was Noida. In the second condition, city was Noida. In the third condition, name was Pratik. And in the fourth condition, name was Pratik. Okay. So or means any one condition can be true. So let's say if you write like this, select name from persons. Okay. So can you see any duplicates here? So the name is Pratik. Okay. So let's say if I want to print, if I want to output only the unique names. So we need to use the distinct keyword for that. Okay. We need to use the distinct keyword for it. So you write like this, select distinct name from persons. Okay. So it will only give me the unique names. So the distinct keyword is only used to give the unique names. You can also write it like this, select distinct city from persons. So it will give me the distinct city. You can see that Noida is not repeated. Now we have operators. Okay. So in SQL, we have operators of different types. Okay. So most of these operators you must have heard previously, but there are a few operators which will be new to you. So this equals, greater than, less than, greater than equal to, not equal to. These all are basic arithmetic operators. Let me just quickly show you one demonstration of it. So let's say you write here, select star from persons. Okay. Now let's say you write like this, select star from persons where ID is greater than 103. Okay. So it will give me 104, 105 and 106 because here it is comparing the integer using the greater than operator. So in this way, you can use the arithmetic operators here. And this AND operator basically will check that all the conditions should be true, or will check that any of the conditions can be true. Not is basically a negation, that means not true. And then we have this between operator. So this between operator is used for range wise queries. Okay. So if I write like this, select star from persons where ID between, let's say 103 and 103 and 106. So it will give me these records where 103 and 106 will be inclusive. So this between operator is very useful when, let's say, you want to query the data on the basis of salary, that give me the salaries of the people whose range is between this and this. Or let's say you want to get the data between two particular dates, let's say the dates are given, let's say 1st Jan and 6th Jan. So you will provide the dates here and you will get the data in between the range using the between operator. Now we have a like operator, which is somewhat complex. Like operator is basically used for string matching. Whatever is the pattern, you will match it like that. So it works in this way. Select star from persons where name like operator is basically for pattern matching. Okay. And then I'll write starting with A. So I'll write A, and percentage means 0 or more than like mean any number of characters. It can be 0, 1, 2, 3, any number of characters. So percentage means any number of characters. But if I write it like this, AM, so it will only give me one record. Why? Because name is starting with AM and percentage means any number of characters. So here you basically you can even specify that, okay, I'll show you. So there are only two wildcards here. One is percentage and one is underscore. So if I write it like this, where name like R, and then I provide two underscores. So underscore means single character only. So underscore means single character. So it will output me only Ram. Why? Because it is of 3 characters. So name is starting with R and then we have 2 characters after it. And if I write it like this, R underscore that is this. So it will give me empty set because there is no such name which has 4 letters and is starting with R. Wildcards, there are only 2. One is percentage and one is underscore. Percentage means any number of characters. Underscore means single character. Single means one, only one character. Now, similarly, we have in operator. So in operator says to specify multiple possible values for a column. Now, let me show you the demonstration of in operator. So let's say you want to get the details of people living in Delhi and Noida. That means multiple values. So in that case, where you have to query multiple values, use the in operator. So you write it like this, select star from persons where city, and then you use the in operator. So inside my in operator, I can write Delhi and then I can write Noida. So what it will do, it will basically match and will give me the results on the basis of it. So if I have to give only city for Delhi only, I can write city is equal to Delhi. But if I have to give multiple criteria, then I will use the in operator. This in operator is very, very important. So please keep this in mind. Okay. Multiple conditions you can provide in the where clause. Let me show you. Let's say I write where city in this and ID is equal to 101. So it will give me only one record because ID is 101 and city should be in Delhi. If I write here, let's say any ID which is not present, let's say 111. So it will give me empty set. So I hope you understood about the basic information, basic knowledge about all the operators. Arithmetic ones is very easy and or is also very easy. Only this between like and in, you will be, it will be something new to all of you. So here, like I told you that we have this AND operator. So this AND operator is basically all the conditions should be true. You can provide any number of conditions, 1, 2, 3, 4 doesn't matter. And if they are all separated by AND, so all should be true. So an example is given here that let's say you need to find all the female French students. Okay, female French students. So that means the two conditions are mentioned here. First, the country should be France. So we wrote it as country is equal to France and gender is equal to female. So your query will be like this. Now, let's study about the OR operator. OR operator, as I told you, that any one condition should be true. So find all the students who are either French or Australian. Okay, so you can write select star from user where country is equal to France or country is equal to Australia. So since here are multiple criteria, so either you can use or condition like this where country is equal to France or country is equal to Australia. But the drawback of here is you need to write this country again and again. Instead, what you can do, you can use the in operator. So you can use select star from user where country in France, Australia. Similarly, we have this not operator. Let's say the query is like this, find all the students who are not Danish. So you will write select star from user where not country is equal to DE. So it will give me all the results except the country DE. Now we have this between operator. So between operator is for range values, all inclusive. So let's say the query is that find all the students who are between 20 and 30 years old. So you will write where age between 20 and 30. And this like operator, so like operator, I have given you the introduction today, but I will pick up this later on also. Okay, so I told you that we have here two wildcards. So one is this percentage. Percentage means 0, 1 or more characters. Underscore means a single character. So let's take an example. Let's take a few examples. Let's say it is written first name like TO percentage. That means first name starts with TO. Okay, here in the comment section is also written here. Select all the first names starting with TO. If it is written percentage AN, that means percentage means any number of characters, but the last character should be AN. That means select all the first names ending with AN. Third example is percentage ICK percentage. That means any number of characters, ICK, and then any number of characters. So that means select all the first name containing ICK. And finally, we have first name like underscore A percentage. Underscore means single character. So select all the first names with second character as A. So first character can be anything, second character should be A, and rest it can be anything. We can also delete the records. So the delete operation is very simple. So the delete operation is delete from, just like we have select star from, for this we have delete from persons, and here also we have where condition. So let's say where city is equal to Hyderabad. City is equal to Hyderabad. So it will say query, okay, one row affected. Now let me just read the data. So it has basically deleted all the records which were matching city is equal to Hyderabad. What will happen if we are not providing any where clause in the select condition? If we are not providing the where clause, it will basically delete all the records from my table. That's why it is shown here 5 rows affected. So when I run the command select star from persons, it will show me the empty data set. If by mistaken you have deleted all the records, there is no way you can get it back. So that is why, just mark my words, whenever you are using this delete operation, okay, just mark my words, don't do this mistake. Please take care of this, that you are using the where condition. See, there are two things in SQL. First thing, delete, and second thing is drop. So when you are talking about delete basically delete the rows, okay, but the table still exists. Table still exists in our database. Let me show you. Show tables. So the table is still there. It is just deleting the records. Delete operation just deletes the records and not the table, but the table still exists. Now let's say how to remove this table from our database. So that operation is used by the drop command. If you want to remove the table from the database, that will be done with the drop command. So the command is very simple. The command is very simple. You need to do drop table and then the table name. Drop table and then the table name. So this drop command will not only remove the entire records, but also the table from the database. So when I run this, you can say the query, okay, 0 rows affected. Now when I do this show tables, it is showing me empty set. Previously it was showing me persons. Now it is showing me empty set. Why? Because I have dropped the table. Now let's see my databases. These are my databases. Similarly, you can drop the complete database as well using the drop database command. So in the beginning of the lecture, I told you that the commands are mostly similar. We have create table, create database. Similarly, we have drop table, drop database. So drop database and then the database name. Okay. Now when I run this, it will not only delete the entire data, but also the complete database from my system. Now when I run this show database, you can see that people info DB is not there. Previously, there were 7 records. Now there are only 6 records. So these are all the basic operations which we have studied up till now: creating and dropping the database, creating and dropping a table, selecting the data, deleting the data, inserting the data, and reading the data with the where conditions. Let's say you have 2 DBs. One is your database 1, and in this you have 2 tables: orders table, and then you have, let's say, customers table. Now let's say you have one more database, and that database is database 2. Okay, in that you have, let's say, finance table, and again you have customers table. Okay, so as I told you that within a database you can't have duplicate names of the table.
Now, also, you can't have duplicate database names. So this is database 1, database 2, but you can't have duplicate database names. Now, if you want to reference customers table from database 1, so one step is, method 1 is go to show databases, okay, show databases, and then use database 1, okay, and then go to show tables, and then do select star from this customers table. Clear? Either you can do this, or maybe we can eliminate this step because you already know what is the table name inside it. So you can do it like this: show databases, use database 1, and select star from customers table. But there is a better way to do it, okay? Method 2, and this is somewhat better way. So what is this way? You just go select, you don't go to show database or select any database. Don't do it. Simply write select star from database 1 dot, and what is the table inside it? Customers table. Also you can do it like this: select star from database 2 dot customers table. You can do it like this. So in this case, you don't have to go any particular database and use that database and then select the table. You can just reference it like this: database dot customers table. So let me write down the syntax here. Although the syntax is very simple, you can do it like this: database name dot table name. So please remember this method to access it to any database, any table. Or you can do it like this. Let's say database 2 dot customers table, finance table, sorry. This is a very easy thing, just I wanted to tell you. Now here, let's say these are my databases, okay? So let's say this is my database, okay? So let's select any particular database. Let's say I go with, what was the previous database I selected? EdYoda DB. Okay, let's use this only. Okay, now let's check out the tables here. Now here we have this employees table. Let's read what is inside it. Employees. So this is my basic employees table. Now in this employees table, we have a couple of columns. We have employee number, we have the first name, last name, and we have the salary of that person, and we have the department IDs. So as you can see from the table, there are a few persons who belong to department ID 500. There are a few persons who belong to department ID 501, some from 503, and some from 504. Okay, so it's just a dummy data. Now, if I want to ask, is my first name column, just analyze this column, is this sorted in the ascending order alphabetically? Okay, and is my salary column sorted? No. So in SQL, we have a command that is order by, and the same command is used to sort the column either in alphabetically or from lowest number to highest number. We have a command order by, and that order by command is used to sort the results. So what are the two types of sorting that we have? Ascending and descending. So we have like this: either you can sort in the ascending order or you can sort in the descending order. Okay, let me show you with an example. So let's say you write like this: select star from employees and then use order by. So order by will be on my first name column. So if you are not providing any parameter like ascending or descending, by default it will sort in the ascending order only. So if I'm not providing any parameter by default, so it will sort in the ascending order. So let me show you like this. So now you can see it has sorted my results in the ascending order, and the results are same even if I provide the ascending parameter, that is ascending condition, that is ASC. Okay, then also the results are same. Okay, doesn't matter. So the results are same. Okay, now if I write here descending order, DESC, so ASC is for ascending and DESC is for descending. So if I write in the descending order, so it will sort my results in the descending order. So this order by command is very simple to use. So the same order by command, just only two parameters you need to pass, ascending or descending. Okay, let me try it in the salary also. So if I write salary, same order by command will be used. So you can see that my salary column has been arranged in the ascending order, 10,000 being the lowest and 20,000 being the highest. And if I write in the descending order, then it will sort in the descending order, 20,000 being the highest and 10,000 being the lowest. So order by is used to sort the result either in the ascending or descending order. First thing. Second thing, if you want to sort the results in the alphabetical order, or you want to sort any integers, same order by command will be used. And the third point to remember is, if you're not specifying anything, by default it will sort in the ascending order, and if you want to sort in the descending order, you need to provide DESC. Now next we are going to learn about one of the most important topics in SQL. Although it's a very easy topic, but there are few critical points that you need to remember. So please pay attention here only. A lot of interview questions are asked on this topic, around this topic, in fact. And also when you will be working with the real data, then also it will be widely used. So before starting that topic, I would like to give introduction to few functions. So let me just quickly give you the introduction. Okay, let me just delete this. So there are a few aggregate functions in SQL. Okay, there are a few aggregate functions in SQL, and those aggregate functions are sum, max, min, count, and average. Okay, I think the meaning of all the functions are self-explanatory. Sum is used to calculate the sum of all the values in a particular column. Max and min are used to get the maximum and minimum value in a particular column. Count is basically used to count the number of rows in a particular column, and average is used to calculate the average of all the values in a particular column. I think this is very easy to remember. Only 5 functions are there: sum, max, min, count, and average. More detail will be followed up in the upcoming sessions. Don't worry about it. I just wanted to give you introduction to it, so that's why I'm stating it right here to make things easy for you. But remembering is very easy: sum, max, min, count, and average. Now let me show you the use of it, the practical use of it. That is also very easy. So let's say I want to get the maximum salary from my employees table. So we will write it like this: select max salary from employees table. So it gives me the maximum salary. Similarly, we can give the minimum salary. So we get the minimum salary. We can also get the sum of all the salaries. Okay, so we got the sum of all the salaries. Okay, and the one which is widely used, that is count function. Count function is basically used to count the number of rows. Okay, so I think this should be very easy to learn. The syntax is very simple. Just write the function and just specify one column name inside it. I'm teaching you this right now because I want to teach the upcoming topic. So this forms the basis of it. Now, let's say I write like this: see that employees table data. What is the maximum salary in department ID 500? What will be your answer? Now for department ID 501, it's 10,000. For department ID 503 is 10,000, and department ID 504, it is 12,000. Now, how did you got the answer? How did you identify that, okay, in department ID 500, we have 20,000 as the maximum salary? You are basically grouping all these rows into one category and then calculating the maximum salary. Because if you used only select max salary, then you will get the salary which is the maximum salary in the complete column. But now when I ask you what is the maximum salary department wise, so you will group these rows into one category. Let's say these 3 rows into one category. Let me just mark them. Yes, these 3 rows into one category, and then you are giving the maximum salary. Similarly, for department ID 501, you are grouping these 2 rows and then you are checking what is the maximum salary. Similarly, for department ID 503, you are grouping this one row and checking the maximum salary. And same goes for department ID 504 and for other rows as well, which will be in the future. Now, let me show you a group by example and then I will explain you. So let's say my question is that I want to get the highest salary from every department. get highest salary from every department. This is my question. So now what will be my syntax? Okay, what will be my syntax? Let me clear the screen and show you here. Yeah. So now if we want to get the highest salary from every department, what we will do, just follow with me and then I will explain you every step. Let's say I want department ID, select department ID, comma, max salary from employees table, group by department ID. So when I run this, you can see that for department ID 500, I got 20,000 as the answer. For 501, 10,000, 503, 10,000, and for 504, 12,000. So what happened here is we use the group by operation. What it does, this group by do is that it groups the rows based on the department ID. So that means it will group the rows with department ID 500 into one single category. And when it has grouped the rows, then it will check what is the highest salary and it will output it here. This one point I missed. So we can use aggregate functions with the group by operation. So you can either use it like this. So here you will get the summation of salaries, or you can get a count salary, count. So you can see that how many employees, how many salaries are there in every department. So for 500, we have 3 rows, 501, we have 2 rows, 503 and 504, we have 1 row each. Now, there is one very important point which you need to remember. I'm writing here so that it stays with you. You can't use where clause with group by operation. Clear? Just mark my words because people generally forget it. For this where clause, we have something different which I'll just tell you next. But remember this where clause can't be used with the group by operation. This group by is used for aggregate functions, right? So we have something different for it. So let's say if I write it like this, where department ID is equal to 500. Okay, so this won't work. It will give me a syntax error. Why? Because where clause can't be used with the group by operation. So what should we use instead of where clause? We use having. Having is used with group by operation. Please remember these 2 points. You can't use where clause with the group by operation, and having is used with the group by operation. So let me show you the having clause. So you write it like this: group by department ID, having department ID is equal to 500. Okay, so instead of where clause, you use having, and then you will get the expected answer. Please study these 2 queries very sincerely. Okay, the operation is seen. Here we are using where clause, so it won't work. Why? Because we have a group by operation. So instead of where, we use having. Having is used with the group by operation. So that is all for now about this group by operation. More detailing, more practice will be done later. Now, next topic is relatively very easy. So let's say you have 10,000 records. But if you are only interested to see what is the sample records, you don't want to load all the records. So basically in SQL, you have a functionality to limit the number of records that you are outputting it. Okay, so the syntax is very simple, and that's the simplest of all. So you write like this: select star from employees. So how many records are there right now when I'm not providing any limit? 7. Okay, so now, as I told you, that in SQL we can also limit the number of records we are outputting. Let's say if there are 1,000 rows, so we don't need to load all the rows, right? So we can limit it using the limit operation. So all you have to do is write limit, let's say 3. Then you will get only 3 records. If you write limit 1, then you will only get 1 record. If you write limit, let's say 100, you will get all the records because there are 7 records. You are providing limit 100, so it will load all the records. Very easy topic. Now, let me just give you one instance here only. Let's say there is one more topic, that is offset. And just like having is used with group by, similarly, offset is used with limit only. So what does offset does? Let's say you write like this: limit 3, and you provide offset as 2. So offset means how many rows you are skipping. So let's say if I give the output, it will skip the first 2 rows and then it will give the output. So it is skipping first 2 rows, that is employee number 1001 and 1002, and then it was giving me 3 results. Why? Because the limit is 3. If I write offset as 3, then it will skip first 3 rows and then it will give me 3 records. So offset is basically used to skip the top rows. So this limit and offset topic is this only. Limit is basically used to limit the number of rows that we see, and offset is basically used to skip the number of rows. Now, so let's learn about this alter command. Let me just write it down here. So this alter command is basically used to, what can I say, add, delete, let's say modify. Yeah, add, delete, or modify the existing columns in the table. Okay, add, delete, modify existing columns in the table. Let me show you. So let's say you have this table. Select star from this employees table. Now, when you are creating the table from scratch, you use the create table command. But now let's say your table is already created and data is already present. Now you want to add a new column. So what should we do in that case? We have a alter table command. So you do it like this way, alter table, and then you provide the table name. Okay, let me first provide you the syntax. So we have this alter table, and then you provide the table name, alter table, table name, and then you just write add column name, and then you provide the data type. What's the data type? This is your alter command. So let me write down here. So let's say alter table, and you write alter table employees, and let's say you write a email column, and let's specify the data type. So my data type is, let's say, varchar. Let's provide the maximum size 255, and then, so when I will again read this table, so you can see my email column has been added. Okay, using the alter command, my email column has been added. There are a few modifications to it that I will run later on, but I can show you here only. So with alter table, you can add a column just like I told you here. You can also delete a column. So for deleting, you use the drop operation. Okay, so you just write it like this, alter table, drop column. Also, you can modify the data type of any column. Let's say you want to change the data type from integer to float, then you can do it that also, which I will tell you later on. But now for our ease, let's stick to these two columns only. Okay, how to update this value? For inserting the record, we know that you need to do the insert into command. But how to update this value? So let's learn about the update command as well. So update command works in this way. You write update. What do you need to update? Your table. Now, this update command has two commands, update keyword and set keyword. So you will write like this, set email is equal to, let's say you provide any email, let's say alfred@gmail.com. Any email ID I'm giving here. Set email is equal to this. And what will be my where condition? What will be my where condition, guys? Employee number is equal to 1001. So when I run this, it says rows matched 1. That means my where clause is matching one record. So now let's check my table. So you can see that my table has, this record has been updated. So the command is like this, update table, and then set what is the column value and where it matches this. Please read this command, very easy to learn. Now, a very simple question. Let's say intentionally or unintentionally, if you eliminate this where clause, what will happen? So now you can see that if you forgot to write the where clause, it updated for all the emails, for all the users, for all the employees, sorry. So also use this update command very carefully with the proper where clause. So now we are going to understand a very, very important topic that is one of the most important topics in the interviews. And that's a very vast topic to understand. So we will be covering in bits so that you are able to understand. So let me show you this, okay, with an example. For now, I'm just going to give you the simplest of all the examples so that you are able to understand. Okay, so let's go step by step. So let's say you have table. This is your table. Let's say you have the customers table. And since this is the very important topic, so I will go as slow as possible and in very detail. Okay, so let's do some formatting. Okay, So you have one customers table, and let's say you have one orders table. Okay, there are two tables. Now let's put some data here. So we have customer ID, and let's say we have name. Now here, let's say we have three columns. Let's say we have order ID, and let's say we have the amount, and we have the customer amount. And for simplification purpose, let's keep the same names, but even if the names are different, doesn't matter. We have customer ID. So we have two tables. How many columns are there in this table? Two columns. And how many columns are there in the orders table? Three columns. Now let's quickly put some dummy data here. Okay, so I'm keeping here 5 records, putting any random names here. Let's say John, David. Again, let's say John is one more time with different customer ID. And let's say one is Betty. Okay, and now let's say we have order IDs. Okay, so few order IDs are given here, 1 2 3 4 5. Let's put some random amounts here. So let's say order ID 1 was 200. Let's say this is 500. Let's say this is 300. Any random values I'm putting here, 800. And let's say now let's also put some customer IDs here. So let's say customer number 10 place this order. Let's say customer number 3 place this order. Let's say customer number 6 place this order, and customer number 5 and customer number 8. Let me explain you quickly. Here we have different customer IDs and the names are given here. We have different order IDs. We have the amount associated with every order, and we have the customer who placed these orders. Now let's say we are joining these two tables. So there is a joint operation, and this is my final table. We are going to do a final table. This is my final table. And why this is final table? Because we are applying a join operation. And let's say, so this is my join operation. Okay, now let's say I'm joining these two tables. Which tables I'm joining? Customers table and orders table. My columns in my final table should look like this. Customer ID, let's say name. So customer ID and name from this table, and let's say amount from this table. I'm joining the two tables. So I'm taking the first two columns from customers table and this third column from this orders table. So this is basically the join operation. Now, out of these two tables, on which column is the common column in these two tables? So let me write it down here only. So in join operation, matching column is customer ID. Now let's join the two tables. So do we have customer ID 1 in this orders table? 3 and 5 are the only matching customer IDs in both these tables. How many of you agree with this? So 3 and 5 are the matching ones. Can we say this, that 3 and 5 are the only matching customer IDs? So I'll write here 3 and then I'll write here 5. So what is the name associated with 3? What is the name associated with customer ID 3? David. And what is the amount associated with customer ID 3? 500. Betty 800. So this is your final table. Okay. So you have basically done the inner join operation. There are other types of join also, but here this is the inner join operation, which is the first join which you will be learning. So here let's sum up whatever have we learned. Okay, so the first thing is to identify the type of join. So here we are doing the inner join. The next thing is you need to identify the matching column. So the matching column is customer ID. And the third thing is you need to filter out the records. This is the most simplified way in which I can teach you this. So there are basically 4 types of joins. Okay, there is inner join, we have left join, right join, and full outer join. So today we are going to learn only about 2 types of join operation: inner join and left join. The best part about this join is that the syntax of all the 4 types of joins is exactly the same. Not a single difference is there, except changing the name of the join operation. So syntax wise, you don't have to worry. Just understand the concept well, and then you are good to go. Now, let's learn about the left join now. Left join is a slightly tricky to understand, but once you understand this, it's very simple moving forward. Now, let me write it down here. This was your inner join. So I'm just copying the same table. Let's delete the records here. So again, what will be the matching column? Matching column will be same, right? For left join also, because that's the only matching column. Now, what is left join? First, let me explain you this. So in left join, this becomes my left table, customers table. Let me write it down here. So my customers table is my left table because it is on the left. Okay, so customers table will be left table. Why? Because the left table is on the left hand side in our diagram. What happens in left join is you output, just listen to my point very carefully, all the records from the left table and only the matching records from the right table. So let me write it down for clarity. All this is given in the slide, so you don't have to worry about it. So left join means all records from left table and only matching records from right table. Okay, so what does this mean? Let's fill this table now on the basis of this definition. So what it is written here? All the records are from left table. So okay, all the records from left table, that means we just have to copy paste this. We have pasted all the records from the left table, and now it is saying that only the matching records from the right table. So what are the matching records? What are the common customer IDs that we identified? 3 and 5. So for customer ID 3, what will be the amount? 500. For customer ID 5, 800. Okay, and rest all the values will be null. So this is basically about left join. This is a very important topic. That's why I'm going as slow as possible. So if you understand this left join, right join is very similar. Right join is all the records from the right table and only the matching records from the left table. The definition is exactly the same. So let me just copy paste this. So what will be my final table? This will be my right join. Matching column will be customer ID and orders table will be my right table. Things are exactly the same. Okay. Now let's go by the definition. What is it written here? All the records from the right table. So which is the column which we are picking from the right table? We are picking amount from the right table, right? Customer ID and name are from the left table. Amount is from the right table. So let me just copy paste this. Okay. Because it is saying that all the records from the right table. So I will just copy paste this. All the records from the right table. Now it says only matching records from the left table. So what are the matching records from the left table, guys? 500 and 800 again. So what is 500 value? David. And what is 800 value? Betty. What is customer ID for David? 3. And what is customer ID for Betty? 5. And rest all will be null. Got my point? So this is your right join. Let me just repeat myself quickly. Here we have assured that customer ID and name will be from the left table only. Whether it is present on the right table or not doesn't matter. We are picking from the left table. That is our choice. Now let's learn about the final join operation, that is the full outer join. Okay, and this full outer join is all records from left and right table, whether they match or not. Full outer join is all the records from the left table and all the records from the right table, whether they are matching or not, whether the customer ID is matching or not. So let me just quickly show you the operation. Let me just copy paste this. Okay, so my final table is using the full outer join operation. Full outer join operation, matching column is customer ID, customers table is my left table, and orders table is my right table. Okay, now let's fill out this table. So here it says all the rows from the left table, all the rows from the right table, whether they are matching or not. So let's first quickly fill all the details from the right table. Okay, because we want all the records. So let's paste here. Okay, I have pasted all the right table. Now let's first fill this. So what are the matching ones? 3 and David, and similarly 5 and Betty. Now it says here all the records from the left table. So how many customer IDs are left now? 2, 4 and 1. Let's write all the remaining records from the left table. So 2, 4 and 1. Now what is customer ID 2, 4 and 1? 2 is Robert, 4 is John, and 1 is again John. 2 is Robert, this is John, and this is again John. And since they don't have any amount, so this value will be null. So now let's fill null in the remaining values, and that's it. So let me repeat what I did here. First, I write all the records from the right table and filled with the respective values, and then all the values from the left table, not including 3 and 5 because they were already included previously. So there is only one thing remaining in this. First thing is definition, and the second thing is the SQL queries. Okay, first let us start with views. Let us learn each and everything about it. So what is views? I will also show you in the hands-on so that it's easier to understand. Now in SQL, A view is a virtual table based on the result set of a SQL statement. So let's break this statement into few parts. So in SQL, a view is a virtual table based on the result set of a SQL statement. So every SQL query has some results, right? So when you do the select operation, we get to see certain results. So those results, you can basically create a virtual table upon it. Based on those results, you can create a virtual table. What do we mean by virtual table? That I'll explain you. Now, a view contains rows and columns, just like a real table. Okay, it is exactly the same. The fields in a view are fields from one or more real tables in the database. This point I will explain you with an example. Now, you can add SQL statements and functions to a view and present the data as if the data were coming from one single table. So what does this mean? That when you are combining the tables, when you're combining the rows and you are creating the view upon it, so you can present the data as if the data were coming from one single table. And the last point is that a view is created with the create view statement. So now too much of terms, too much of terminologies and too much of things are given here. So let's break each and everything and I'll explain you. Before starting, first, which query took the most time to write, like complexity wise or terms wise? The correct answer is you can say that the join operation. The join operation was up till now the most complex and the most time taking query because 4 to 5 statements are involved in it. Now, let me give you one example and then you will get to know automatically what is the significance of views. We took the example of this customers and orders table, right? So let me just copy paste it and show you in the separate sheet so that you are able to understand it. Let's delete the unnecessary information. Now let's say you are working with data. Now let's say you are using these two tables. One is the customers table and one is the orders table. Now let's say on daily basis, you need certain fields. So let's say I want customer ID and then let's say I want the name of the customer and what is the order that he placed. So can we say that this is the invoice table, or let's say not table because we are not in fact creating any table. Let's say that this is the invoice data. So let's say your manager says that you need to generate daily invoices and that daily invoices should include what was the customer, what was the name of it, and what order did he placed. So let's say customer ID 1. I'm just taking any random example. Don't go with the data. Let's say the order place is this. Let's say this is this, and this. So this is your sample invoice data. So now this is your step 1. Okay, because you are dealing with invoice data. So you will create a table like this. Let me just make it in a single color so that it's easy to learn. So this is my table. And since I'm dealing with invoice data on daily basis, so this is the data I will create. Now let's say your manager asks you that do certain operations on it. Those certain operations can be, let's say, get count of total orders, or let's say get details of customer ID. Let's say any customer ID, XYZ. This is any number XYZ. Or let's say third example can be that get details of this person whose name is, let's say, anything, any name is given here. Okay, just a simple example. Okay, or anything can be there. Let's say do a group by operation. Group by operation can also be there. Okay, so there are multiple things that you can do on this invoice data. There are multiple things that you can do on this data. If you want to do the count, which function you will use? Count function. If you want to do get details, you will just use simple select operation. If you want to do name, then also you will do simple select operation. And here you will do a simple group by operation. All these operations like this count operation, select operation, and group by, these are very short queries. But this query that is joining, this is joining the operation, right? So since step 1 is my join operation, so let me write down here that this is my join operation. So only for doing these simple one-liner operations, you have to write this complex join query again and again. That let's say you just want to get the details of this person, let's say John. So just for doing this select star from table where name is equal to John, you first need to join the two tables and then you need to do the select operation. So what I meant to say is
that to save our time and to save our resources. So what we can do here is we can basically create a view. Okay, here the view comes into place, view comes into picture. We can create a view. So what does view means? View basically create a table, a virtual table on this result, this invoice data that we have created. It is the result of join query. So we are creating a view on this join query. Let's say the name of the view is invoice. What will happen? You will create the view once, and after that, you can write the simple queries as you were writing previously. So you will write select star from invoice, where let's say customer ID is equal to anything. You can write XYZ, any value you can give. So instead of writing like select star from customers inner join orders on matching column where condition, you will simply write like this: select star from invoice where customer ID is equal to XYZ. So let's come back to our slide. So it's written here, a view is a virtual table based on the result set of a SQL statement. So what was the SQL statement in our previous example? It was the join operation. What was the result set? Invoice data. So we are creating a virtual table on the invoice data of the join operation. Now, a view contains rows and columns, just like a real table. That's also we just saw right now. And the fields in a view are fields from one or more real tables in the database. So what are real tables? Customers and orders table. Those are the real tables which you are actually creating with the create table command. This view you are not creating with the create table command. But so we are basically getting the rows and columns from the real table inside a view. The third statement is you can add SQL statements and functions to a view and present the data as if the data were coming from one single table. Now let's see what is written here. So if you run this statement, you can clearly see that you can say that the data is coming from one single table, the invoice table. In the background, we can't check that whether it is coming from two or more tables. But here you can clearly see that the data is coming from the single table. So that's all what is written here. Now, what is the significance of views? Okay, so 1-2 advantages we already studied, but let's study about this completely. So views increases reusability. We have basically created the view once and then we can use it multiple times. Just like in programming, you have functions. So what this function does? You basically create the function once and then you can use it n number of times. Similarly, the views, you just create the view once and you can use it n number of times. So now let's discuss the next point. Views help in data security. You can use views to show only authorized information to users and hide sensitive data like credit card numbers. So let's understand this very important point. Okay, it also helps in data security. Let's see how. So let's say you have the finance table. Now, everyone knows that the finance table and where the money is involved, the finances are involved, that data is very important as far as data security is concerned. So now, let's say in your finance table, you have certain fields. Let's say name, and let's say address, phone number, let's say credit card number, and let's say bank details, and let's say CVV number is also there, or let's say security code is also there. Any field that is security code. So can you guys observe that a lot of critical information is present here? Okay, so this is my finance table, which has a lot of critical information. Now, if by any chance you get the name of the table finance, very easily you can do this operation, select star from finance, and this will result in leaking all your data. Let's say ideally you just want to share these three fields. Let's say name, address, and bank details. Okay, but this credit card number and security code are very, very important. And let's say you don't want to share this. Okay, let's say from this table, you don't want to share this field and you don't want to share this field. You only want to share this field out of this field, but you can't stop anyone from doing it, right? He or she will just run this simple command and all your data will be leaked. So in this case also, we use the concept of views. So what we can do here, we can create the result set. So we can basically create a view. Let's say, I'm not writing the exact sentence, just the logical view. So we can create a view, and what will be view? View will be select name, address, phone number, and let's say bank details from finance table. So this is my query. And what will be the result set? This will be the result set of this query. So basically we are creating a view on this table. Now let's say the name of the view is anything, let's say customer information, bank customer. So now even if you do select star from bank customer, you are still hiding this information. Now the third point is, if you have any frequently used complex query, you can create a view based on it so that you can reference to the view by using a simple select statement instead of typing the query all over again. So this we already studied with a detailed example. So here it is written clearly that if you have a frequently used complex query, just like the join operation, so you can create a view once and you can reference it by using a simple select statement instead of typing the query all over again. This we already seen with a detailed example. So in the notes section, it is only written here. That's just like the table names are unique, database names are unique. So views names are also unique because views also occupy some space in the database. So the view names are also unique. So let's move forward. Now, this is your syntax. And then I'll also show you an example and the hands-on. So the syntax is very simple. The rest of the 3 lines are your basic select operation, select from where. The syntax is just a one-liner. Create view, view name as. That's it. It's very easy to create a view. Let me show you now with an example. Now, for now, I will just quickly show you a very easy example. So let's say I go to this DB, EdYoda DB, and I click on show tables. So here we have departments. Let's go to departments. If we have some relevant records here, let's go to employees. Employees is fine. Now let's say you are only interested in people working in department ID 500. There are a couple of more department IDs given here. So what you can do here, you can basically create a view on this simple result set. So let's say I'm writing here, create view. So syntax is just one liner, create view. The view name is, let's say, department 500, department 500, and then you will write as. So this is a one liner statement. So what will be my SQL query? So we will write select star from employees where department ID equals to 500. So very simple query. It's just we are creating a view on it. Okay. Now let's try and running it. So it says query okay, 0 rows affected. Now we will just simply write select star from department 500 because this is my result set, a virtual table. So you can see that I got all the results from department ID 500. Since I'm not interested in other departments, so I won't output them. So I can simply write like where employee number in, let's say 1001 and let's say 1003, any simple query. So it will work pretty much fine. Okay, you don't need to query this big table, employees table again and again when you are interested only in this subset. So this is also one use case of views. So let's say you have here all the information. Let's say you have employee number, you have, let's go back to our employees table. So this is my employees table. So here you have all or pretty much all the information: employee number, first name, last name, salary, department ID, and email. Now let's say you are giving me the example that let's say you want to hide the salary. Let's say salary is the critical information and you don't want to show the salary. So what you will do, you can basically do create view, and let me give the view name. So let's say view name is employee emp employee info as. Then mention the columns that you want to select. So let's say employee number, let's say first name, and let's say department. Only general information, that what is the employee number, what is the name, and to which department he or she belongs. So when I run this, unknown column employee number in the field is, oh sorry, my mistake, I forgot to mention the from employees table. That's why it was giving error. So now you can simply write like this, select star from employee info. Okay, so you are basically hiding all the critical information, you are just showing the general information. So now this was basically about creating your views. Now there are certain limitations in views also, like it's not fully advantageous. There are few limitations also. Let's say you want to update your table. So through which command do we update our table? The update command. So you can simply write update table and then set. But now if we talk about updating the views, there are a few limitations. There are certain conditions which needs to followed, and if those conditions are met, then only you will be able to update the view. So let's go through the slide, what is written here. So a view can be updated under certain conditions which are given below. The conditions are: select clause may not contain the keyword distinct. Select clause may not contain summary functions. Summary functions are basically your aggregate functions. Some select clause may not contain set functions, set operators, order by, and the from clause may not contain multiple tables. That is no join operation. The where clause may not contain subqueries. Subqueries we will be learning in later part of the series. The query may not contain group by or having, and the calculated columns may not be updated. Calculated columns also we will study. It's a very easy topic. And all not null columns from the base table must be included in the view in order for the insert query to function. So if all these conditions are met, that is your select operation should not contain distinct function, summary function, set function, order by, subquery. There are a lot of, so if all of these conditions are met, then only you will be able to update your view. Otherwise not. So only limitations is while updating the view. Rest all is fine. Let's move on. Now, before I move forward, there is one thing which I needed to tell you. If I run this command, now, show tables, you can see that the recently created views, that is department 500 and employee information, are both shown under my tables command, show tables command. Can you guys observe this? These are the two views which we created, department 500 and employee information. Also the previously created views which I created earlier are also mentioned here. So basically all your tables and all your views are shown in this show tables command. So that means views is treated like a table only. Now if you want to drop any view also, let's say you want to drop, then the command is same: drop database, drop table, drop view. All are same. Okay, they are all used with the drop command. So you will just simply write drop view. Let's say I'm dropping this view one, or let's say this one only, department 500, because we just created it. Okay, it says query. Okay, now when I again see, you can see that previously there were 13 rows. Now there are only 12 rows left because we deleted this department 500 view. Okay, let's move forward. Let's see a very complex query. Okay, it doesn't matter if you understand the query. Understanding the query is not important. How to create the view is important. Let's say here 3 different tables are given. Okay, one table is orders, and we can alias is A. Alias I told you in the previous class, that is temporarily renaming it. So let's say we have table ABC, that is orders, customers and agents respectively. Now let's say we want to join these tables. We want to join these 3 tables. So please look into the data very carefully and identify the matching column. The answer is agent code. Why agent code? Because agent code is matching in all these 3 columns, on these 3 tables. So on the basis of agent code, you can basically join the 3 tables. Now let's study the query. So as I told you that the create view command is a one-liner. So that is written in the line 1. Let's go through each and every line, even if you're not able to understand this complex query, because here we are joining not 2 but 3 tables. So even if you're not able to understand the query, doesn't matter. Understanding that why views is important here. So the command is like this. Let's break it into few parts. First part, create view command. Second and third line, here we are selecting the columns based on our choice. Let's say order number, order amount, agent code from table A, agent name and customer name. Then line number 4 is your simple where command, from command. So we want from orders, customers and agents. So orders as A, customer as B, agents as C. And the 5th and 6th statement is simply your inner join query, that you are joining table A and table B on the basis of customer code, and you are joining table A and C on the basis of agent code. The query is very simple. We are just creating the view on this complex query. So what I meant to say here is, let's say you are working on some data which uses these 3 tables. So as I gave you the earlier example, the example is similar, that for using the simple operation, you have to write this 6 lines again and again. So instead, what we can do, we can create the view once, just like this, and the view name is orders view, and then you can use it like a normal table. So the important part here is to understand why this query is important, why this views is important, because it helps us to simplify the process. Let's move further. Now let's understand a theoretical topic. Now let's go with keys. So let's first understand the formal definition. So keys in DBMS is an attribute or a set of attribute which helps you to identify a row in a relation. So there are a couple of terms written here. So what are keys in DBMS? It is an attribute. Attribute is basically another name for column. So keys in DBMS is an attribute, that is a column or a set of columns which helps you to identify a row. Row is also known as a tuple in DBMS. And similarly, in a relation is known as table in DBMS. So if we want to understand this in simple terms, so keys are basically columns or a group of columns which helps to identify a row. They also allow us to find the relation between two tables. So let me just tell you. So there are mainly 8 different types of keys in DBMS, and each key has its different functionality. So like the 8 keys are given here. So super key, primary key, candidate key, alternate, foreign, compound, composite, surrogate key. There are different types of keys. But as far as your course is concerned, on the scope of your course, we are just going to discuss 4 or 5 of them that are the most important ones. Primary key and foreign key I've already taught you, and these were one of the most important and critical ones. So let's understand about rest of them also. So super key is very simple. So a super key is basically, what is super key? It is a group of single or multiple keys which identifies rows in a table. Very simple definition and also not widely used. Super key is a group of single or multiple keys which identifies rows. Primary key, what did I taught you about primary key? It is a column or a group of column in a table that uniquely identifies every row. That is why the name can't be the primary key. Why? Because there can be one or more person who have the same name. But enrollment number can be the primary key. Next, let's skip the candidate key for a minute. Let's study first the foreign key because we have already studied it. So foreign key is a column that creates a relationship between the two tables. The purpose of foreign keys is to maintain the data integrity and allow the navigation between the two instances of an entity. So in simple terms, I taught you about foreign key. So foreign key is a concept that we learned, and that it is basically used to relate the two tables. So this primary key and foreign key has already been taught to you. Now let's talk about candidate key. So the functionality of candidate key is exactly the same as primary key with a minor difference. So here candidate key is a set of attributes that uniquely identifies tuples in a table. So the functionality is exactly the same. Candidate key is the super key with no repeated attributes. That is okay. There is just only one minor difference between primary key and candidate key. So the main difference is that primary key can't have any null values, but candidate key can have null values. So let's say you are declaring any primary key. Let's say you are declaring enrollment number as the primary key. So every student will be having the enrollment number, right? Am I right? So that can't be null. But when you are talking about candidate key, so candidate key can have null values. Now let's go to the next topic. Let's study about this primary key in detail. So primary key constraint, this is a constraint. So primary key constraint uniquely identifies each record in a table. Primary key must contain unique values, already told you, and it can't contain null values, whereas a candidate key can have null values. And a table can have only one primary key in the table. We can have a single primary key only. However, a key can have a combination of single or more than one column. That is a different thing. So let's say if you talk about this employee table. So here already the answer is given that we are declaring employee ID as primary key. So here employee ID can be treated as the primary key, and there can't be any other primary key. Why employee ID is declared as a primary key? Because it can uniquely identify all the employees and it can't be null. Can we keep passport number as primary key? We can keep the passport number as primary key, but it can have the possibility of being null. That is why it's not a suitable option to keep passport number as primary key, because there can't be all the employees which have the passport. So that is why the most appropriate key can be employee ID. Let's go to the next topic. Next is the candidate key. So candidate key also uniquely identifies all the records. It's just that candidate keys can have null values. So here there are, how many candidate keys are given here? 3: passport number, license number, and SSN number. So 3 candidate keys are given here, and it can be null, so it doesn't matter. Also, we can have a single candidate key, which is a combination of these 3 columns, that is attributes, passport number, license, and SSN. Any combination we can take. Okay, let's move forward. Super key is very simple and is not much used. It's just a superset of any key, so it doesn't matter, and it also does not identify uniquely the record. Okay, so it's not of much significance. Let's skip it. Composite key is also very simple. That is a primary key consisting of more than one attribute, known as composite key. Not widely used, but still good to know. The most important ones are primary key and candidate key and foreign key. Now let's learn about the foreign key in detail. So before again showing you the foreign key, let's just revise it. So here I told you that we have a customers table and we have the orders table. And here I told you that customer ID is the primary key. Now, if customer ID is the primary key, and let's say just for our ease, let's delete this customer ID. Let's keep it the customer column. Now I'm saying that this customer column is referencing to primary key of customers table. Hence, this customer column will be known as the foreign key. Customer ID from the orders table, customer from orders table references customer ID from the customers table. That means these 2 columns are related. So if these 2 columns are related and this column is referencing this column, then this will be known as the foreign key. Okay. So this was about foreign key. Now let's learn what is written here. There are some new points written here. So a foreign key constraint is used to prevent the actions that would destroy the links between 2 tables. So let's say you decide to delete, let's say, this column. So you can't simply do the alter table drop command, because this column is basically creating the link between the 2 tables. So it will throw the error. That is why it is written here, that is used to prevent the actions that would destroy the links between the tables. So that's a check that you are keeping on while doing the create table command. So that's a constraint. That's a data check. Now the second point is a foreign key in one table refers to the primary key in the another table. That's the most simplest definition that you should remember, that a foreign key is a field that refers to the primary key in another table. Many a times in interviews, people get confused that what was the primary key and what was the foreign key. So that's the most simplest definition that can get you through, that a foreign key is a field in one table that refers to the primary key in another table. And the third point is the table with the foreign key is called the child table, and the table with the primary key is called the parent table. So that's a very simple topic that if you're talking here, so the table containing the primary key, it will be the parent table, and this will be a child table, orders table. So let's move forward. So that's just a very simple example. So here, let's say person ID was the primary key. That's why it is written at the first place. So person ID is the primary key. So, and this person ID is referencing to this. Let me just draw it. So this person ID is referencing to the primary key here. So this will be the foreign key. This will be the foreign key, and this is the primary key. So if this is my primary key and this is the column which is referencing to this, so this will be the foreign key. Since we can conclude that this is the foreign key. Got my point related to foreign key? We are discussing one of the most important topics in SQL right now, that is keys, primary key, foreign key, views, and the upcoming topic normalization. All of these are very important topics. So this sums up our keys topic as well. Let me name this topic. This is the normalization topic that we are learning about, and one of the most complex ones, but I'll try my best to make it easier for you. So before starting with this topic, just like always, first we will discuss a use case, we will discuss a case study, and we will discuss an example why this topic is actually important, and then we will continue. So please go through the question given here. So let's consider a single large data set having only single relation. What is relation in DBMS? Table. Okay, and rows as tuples in DBMS. That's a terminology that you need to remember at any cost. So let's say you have a very large relation, that is large table. Here it is written that this large database defined as a single relation may result in data duplication. So let me give you an example. Let's take an example of school database. Now in school database, you can have multiple tables. Let's say you can have student information, you have marks table, you have exam table, or let's say you have fees table. Many tables you can have. If we talk about the students data, But let's say instead of these tables, let's say we are just doing a very bad database design and we are just creating a very large table. And in that single large relation or that single large table, we are having all the columns. Let's say 100, 150 columns, 200 columns are there. In the same table, you are having the student's information, the father's name, Aadhaar number, the fees, marks, everything is present under the single table. Can you imagine this table? How huge will it be? Not depending upon the number of records, but depending upon the number of columns, this will be huge, right? So now my question is, can you think of the disadvantages of having such large database with repetitive data? Obviously, if you have such large table, there will be a lot of data that will be data duplicated. Duplicate records will be present there within a single column and the rows as well. So the repetition of data or the large data may result in making relations very large. Databases will be very huge. Your tables will be very huge, that it is difficult to maintain and update data as it would involve searching many records in relation, wastage and poor utilization of disk space and resources, and the likelihood of errors and inconsistencies increases. If we are having one very large table, so it will result into these many problems. Here we are not talking about any coding part. Here we are not talking about creating table, inserting table, nothing. Here we are just checking how to make a nice and good database design. This is the topic that we are learning right now. So now my next question is, the next brainstorming question is, how should we handle this problem? We should create smaller tables and much organized tables and keep the data separated. And obviously we will create the link between them, but that's a different part. But we will create smaller tables. So the solution is normalization. It is basically breaking your large table. Let's go by the definition. Normalization is basically a process of breaking a large table into simpler, smaller, well-structured tables with fewer attributes. What are attributes? Columns. So the first point is the most important point, that here we are breaking a large table into smaller, simpler, and well-structured tables with fewer columns. The second point is also very obvious, that it is the process of organizing the data in the database. We are organizing the data, right? Instead of very large table, we are making smaller tables and organizing the data into smaller tables. Let's skip the third point for now and go to the fourth point. So what is normalization does? Normalization is a series of guidelines or rules. So there are basically few pointers that how should you create the, or how should you break the bigger table into smaller tables. So normalization consists of a series of guidelines that helps to guide you in creating a good database structure. Don't worry about the third point. We will be discussing the third point in detail with a lot of examples. What is actually normalization? That it is a process of breaking the relations into smaller, simpler, and well-structured relations with fewer attributes. So let's start with this slide only. So what is normalization? It is a process of breaking or decomposing the relations. What are relations? Tables. So basically you are breaking the tables into smaller, simpler, and well-structured relations with fewer attributes. It is the process of organizing the data in the database. Now, let's discuss the third point in detail. So what is written here? It is written here that it is used to minimize the data redundancy from a relation or a set of relations, and is also used to eliminate undesirable characteristics like insertion, updation, and delete anomalies. So there are many terms written here. Let's break the statement and learn about each part bit by bit. It is used to minimize the data redundancy from a relation or a set of relations. That means, first let us discuss what is this term data redundancy. Data redundancy in DBMS means that storing the same data at multiple places. That means it is a repetitive data, storing the same information at multiple places. It is used to minimize the data redundancy from a relation. That means if your data is redundant, it will reduce that point. Okay, it will reduce storing the same data at multiple places. So now let's come to the second part of it. It is written here and is also used to eliminate undesirable characteristics like insertion, updation, and delete anomalies. So let's discuss this point in detail. So let me give you the example. So what are these anomalies in DBMS? Okay, here this is a new term, anomalies, insertion, updation, and deletion anomalies. So let's discuss about this term. So data modification anomalies can be categorized into three types. So one is insertion anomaly, second is deletion anomaly, and third is updation anomaly. So what is insertion anomaly? Insertion anomaly refers to the case when one cannot insert a new tuple into a relationship due to a lack of data. So this is your insertion anomaly. What does insertion anomaly means? The issue you are facing while inserting the data, the issues you are facing while inserting the data. So this means insertion anomaly refers to when one cannot insert a new tuple into a relationship due to a lack of data. Let me give you the example. Now let's say we are taking example of very large data. Large table as means large number of attributes. Large number of attributes. Okay. So this is a single table having large number of attributes. So let's say which example should we take? Let's say we are taking a database of school. So we are taking about school table, school table. So let's say there is serial number. Here is name, father's name, let's say phone number, let's say address. And this is the general information. Now, this is the general information that is fine. But now in the same table, we are having marks also. Marks obtained in let's say these are marks 2 in subject 2, marks in subject 3, marks in subject 4, and so on and so forth. And in the same table, we have fees information also. Let's say fees, date, fees amount, and so on and so forth. So this is a very large table which is having these information. Now, let's say the data is present here. This is the already existing data of students. This is the already existing data of students. Now, let's say a new admission comes in. Now, can we say that the new admission will have these following details? Admission will be having serial number. Serial number is just your index 1, 2, 3, 4, 5, 6. He will be having the name, father's name, phone, address. He will be having this. But can we say that that student will be having this information also? Is it possible for a new admission? No, right? Okay. So this causes insertion anomaly. Now the example is clear. Okay. So here it is written that one cannot insert a new tuple into a relationship due to a lack of data. Now let me just add one more point here, that why we cannot insert a data. Because let's say the table is created in such a way where we make this fees as not a null. So let's say you created a table, create school table, and here you declared this fees date as not null. This is a constraint. Okay, this is a constraint. This is my create table command. So here in this create table command, I declared that my fees is not null. So here we put a check on the column that our school in our fees date, it can't be null. So the new admission guy will not be able to insert the record, right? So that is why this is known as the insertion anomaly. Now let's go to deletion anomaly. So what is deletion anomaly? The delete anomaly refers to the situation where the deletion of the data results in the unintended loss of some other important data. So let me clear you with this example. So let's say this is your employee table. Here you have a single table and not proper smaller tables. Here employee ID is given, employee name is given, employee address is given, and employee department is given. Now just focus on this column, employee department. Here I'm just asking you one thing. What will happen if I, let's say, delete this record? What will happen? We have a single table, employee, and we are deleting this record. We are completely deleting this record. That let's say this employee ID 123 left the company. Now, if this person left the company, the information of department D890 is completely lost from our table. Let me just give you more insight. So let's say if this person 123 leaves the company, this record will be deleted. And if this record gets deleted, we can't have any information that if in this in this company, department D890 ever existed. So ideally, what should we do? We should have two tables, one table for employee information and one table for department information. So even if this person leaves the company, we still have the information that, okay, there is any department which is D890. So this is basically your deletion anomaly. That means it refers to the situation where the deletion of data, what was the data that we were deleting? 123 employee ID, results in the unintended loss of some other important data. So this was unintended. This was not by choice. This was by mistake. You were trying to delete the information from 110, 123. That is fine. But you also deleted the complete information of D890. Ideally, what should we do? That we should have two tables, one for employees and one for employee department. So even if this person leaves the company, we still have the information that, okay, D890 is a department where there is no employee. Let's learn about the third point. What does the third point say? The updation anomaly. Updation anomaly means the issue which you are facing or which you can face while updating the data. So update anomaly is when an update of a single data value requires multiple rows of data to be updated. Let me give you the example. Let's say, can you see the first two records? Now, what is the difference between first two records? Employee ID is same,
Um,
employee name is same, address is same. But why is
Department.
the department different? Because let's say that person was initially working in department D001, and after few months he changed his department and he switched to department D002. So we have both the records, right? And there is no fault in having both the records, because first we are having of entry D001 and now we are having entry of D002. But what is the problem in this? First problem is, let's say this person Rick decides to change his address. Now let's say he changes Delhi to Bangalore. He decides to change his address. Now, in that case, first we have to search for all the employees who are having ID, employee ID 101 and name break. And then we have to update the records of all such records. We have to update the address of all such records. So this clearly creates an overhead for us, because instead of updating the data, first you have to search for all of the records that is matching with our query, and then you have to update the records. So this is creating a time increase, right? And memory increase also. So that is why it is written here that the update anomaly is when an update of a single data value requires multiple rows of data to be updated. Ideally, what should we do? Search for an employee ID, update the information. But in this case, we have to search for all the records that are matching our query and then update the record. These are few of the consequences that we can face which when we are having a large table. Now, to solve these problems, whatever issues we have discussed, there is a process that is normalization, which helps to remove all of these anomalies, all of these consequences and bad database design problems one by one. So let me discuss about normalization. Let's generate a new term. Let's say after normalizing, your data becomes normalized. Let's introduce a new term, normalized data. So what is normalized data? After you have perform the process of normalization on the raw data, your data becomes normalized. Now, first of all, what happens? Let me give you the general overview of what happens. There are certain rules in normalization, right? So see, what will happen? First, you apply certain rules and you make your data, you convert your data into first normal form. And after that, you apply few more rules to make your data into second normal form. And after that, you perform some more rules to make your data or convert your data into third normal form. There are other normal forms also, like 6NF, BCNF. There are 7, 8 types of them. But for your scope, we are discussing over the three. So first you can apply some rules, make your data into first normal form. Then you apply one more rule, one or two more rules to make your data into second normal form, and then your third normal form. So in other words, we can say that the third normal form is the most strict type of normal form where the possibility of data inconsistency or data duplication will be very low. Or there is some issue understanding this. So let's say this is your data. So you apply certain rules, you convert your data into first normal form, you apply some more rules, you convert your data into second normal form, and then finally you convert your data into third normal form. So here, few of the consistencies will resolve, here few more, and here almost all of the data inconsistencies will be resolved. So in short, we are going to discuss about these rules only. So now first let's discuss about first normal form, that is 1NF. Okay, so for a table to be in the first normal form, it should follow the following four rules. So there are four rules which you need to remember, but there is only one rule which is the most important. So learning these rules is very easy. There will be no problem in learning these rules, and I will try my best to explain you in the most simplest manner so that you don't any rote learn it. But I will explain you so that things are very clear. So we are talking about the first normal form. So there are four rules. The first rule is that it should only have single or atomic valued attributes or columns. What are single valued attributes? Let me give you an example. So let's say how many columns are here? Roll number, name, and subject. Roll number, we have a single value, that is 101. Name, we have a single value. Subject, here we have multi values. Why? Because here we have more than one value. OS and CN is more than one. So this is known as a multi-valued attribute. What is an attribute? Column. So this subject column is multi-valued. Similarly, if you can see the third row, it is multi-valued. C, C++. Two points are here. Two values are here. Multi-value, as the name suggests. So this is known as multi-valued attributes. So here it is written that for a table to be in the first normal form, it should follow the following rules. First rule is it should only have single valued attributes. Second point is values stored in a column should be of the same domain. So this is a very easy point. What does this mean? So let's say if you are having the name column, so it should have only the names only. We should not have any other information in it or any other data type in it. Let's say you declared the data type as string. So it should only have string values. Let's say you declared a data type as integer. So it should only have integer values. That is, the domain should not change. The third point is all the columns in a table should have unique names. That's a very easy point and very self-explanatory. And the fourth point is order in which is data is stored does not matter. So that's not a rule. That's just a general point given here. So the most important point is point one. Now let's understand this example one more time. So after seeing this table, very short table, can we say that the table is in first normal form? Because we have multi-valued attributes. And what is the multi-valued attribute here? I'm
One.
asking what is the multi-valued attribute? So your answer should be
Subject.
subject. What is attribute again? What is attribute? Okay, so when I say that you should not have multi-valued attributes, that means this subject column is creating the issue here. Now, my second question is, how can we solve this problem? What we can do is, we can basically split our rows. In the first row, we will have 101 Acon and OS. In the other row, we will have 101 Acon and CN. So your final data will look like this. So you can see that we have split our attributes, and now my data is in the first normal form because we are not having any multi-valued attributes. This is very simple concept. It's just that you need good mind, a good brainstorming session to analyze how can you make your database design and how can you normalize your data. Otherwise, the rules are very simpler. The first normal form is clear. Now let's go to second normal form. There are only two rules for your data to be in the second normal form or your table to be in the second normal form. The first rule is that your data should be in the first normal form, and second point is that there should be no partial dependency. So if I show you the diagram, I told you in the beginning that first your data needs to be in the first normal form and then only you can make your data into the second normal form. So this is the first point mentioned here, that your data should already be in the first normal form. Let's discuss this second point, that there should be no partial dependency. But what is partial dependency? So let me explain you this term. Let's understand the term dependency first. But everyone should know the term primary key, right? So now let's say this is my students table. Okay, the table name is students and the primary key is student ID. What is student ID? Any attribute which is not unique and not null and is able to identify every other record uniquely. That is known as the primary key. So here we are having student ID is the primary key. We have other columns as well. Student ID, name, registration number, branch, and address. So can we say that if we have a student ID, then that can derive the name information or registration number or branch or address? Can we say this? Let's say you have student ID 10. So with the help of student ID 10, can you like derive the name of the student? Very easy, right? Select name from students where student ID is equal to 10. So that is very easy, right? But is the vice versa true? Can we say that the branch can derive the student ID? Why? Because there are multiple students in the branch CS or IT. So you can't exactly derive the student ID. So that's why it is written here that student ID derives This is the sign of derives, a simple arrow. Student ID derives name. Student ID can derive name and the branch, and the student can ID can derive the name, branch, and address, registration number, anything it can derive. So this is known as the dependency. That every column in my table, whether it is name, registration number, branch, address, or any other column, it is directly dependent on student ID. So this is known as dependency or functional dependency. Functional dependency is the more common term which is used. So this is the functional dependency, when every other column is dependent on the primary key. This dependency term you will hear from my side till the normalization topic is there. Now let's understand what is partial dependency then. So this was functional dependency. Now there is a part of it that is known as the partial dependency. So let's discuss about it. So let's say you have two tables here. One is the subject table and one is, let's say, marks table or score table. You can name anything. So there are two tables. In the first table, you have subject ID and subject name. And in the second table, that is the marks table, you have score ID, student ID, subject ID, what are the marks and what is the teacher. These two tables you have. Now, what will be the primary key in the subject table? Subject ID. Okay. Now, let me give you one example. Okay. Let's forget about the subject table for now. Let's analyze the score table or the marks table. Let's analyze this. Now, let's say I'm saying that student ID plus subject ID, the combination, it is written here in the pink letters, that the combination of this is the primary key. What is primary key? Primary key can be a column or a combination of columns. So let's say this combination is your primary key, student ID and subject ID. Let me just highlight it. This is your primary key. This is your primary key. That means the combination of student and ID and subject ID can uniquely identify all the records. So can we say that student ID and subject ID, that is my primary key, that my primary key can derive marks? Can we say this? In easier terms, let's say you have a student ID 10 and let's say the subject ID 2. So can we derive the marks with the help of student ID and subject ID? Yes. Why? Because let's say you just have to check who is the student and what is the subject he's studying. You can calculate the marks. So this point is valid. Now, is the second point valid? Subject ID and student ID can derive the teacher? Yes. Why? This point is also true. Because if you have the student ID and subject ID, you can check who is the teacher teaching. Because let's say you have student ID 10, roll number 10. What is the subject he's studying? He's studying subject ID 2. So you can easily check what is the teacher related to it. Why? Because the subject ID 1 means Java teacher. Subject ID 2 means C++ teacher. Again, subject ID 1 means Java teacher. Now, is the third point also true? Yes. Why? Because subject ID can alone also derive the teacher. We don't need a student ID. Subject ID can only subject ID can also derive the teacher. Because let's say you have the subject. Every subject is associated with the teacher, right? So you don't need any student's information for it. You can directly link that, okay, subject ID 1 is Java teacher, subject 2 means C++ teacher. So that means all the 3 points written here are true. Then what is the difference between the second point and the third point? Here we can say, just read this point very carefully and listen to me very carefully. Can we say that in the third point, part of primary key is deriving a non-prime key? Can we say this? Here in note section is also written here. This is given in the note also. Teacher column is dependent only on the part of primary key and not the whole primary key. Can we say this? See, this teacher column is dependent only on the subject ID and not on subject ID and student ID. So this means this is the case of partial dependency. Partial dependency means part, partial means half. So partial dependency. If you just remember this definition, then it will be easier for you. When an attribute in a table depends only on a part of the primary key and not on the whole key, then that is known as partial dependency. So let's go back to the 2NF definition, 2NF rules. Here it said that there should be no partial dependency. So that means if we have this case in which a non-prime key attribute is depending on the part of primary key and not the whole key, then this is known as partial dependency. Hence, this partial dependency should be resolved to make our table in the 2NF. So can we say that my score table is not in second normal form? Can we say this? My second question is that if my score table is not in second normal form, then which column is creating the issue? So the correct answer is teacher column is creating the issue. We are not able to declare our table in the second normal form because of the teacher table. So how can we resolve this issue? We have understood that, okay, this table is not in the second normal form, and we also have identified the column which is creating the issue. Then how can we resolve this issue? So there can be multiple ways, but let me discuss one approach. So if this column is creating the issue, let's remove this column from here and attach it here. If this column is creating the issue, let's remove the column from this table and attach it here. So in this way, your scores table, we are basically breaking your scores table into two parts. So the first part is where you are having only the score information, that what is the student and what are the marks. And this in your subject table, you are having the information of subject, what is the subject name, and what teacher is teaching that subject. So your final data will look like this. So the simplest solution is to remove the columns teacher from the scores table and add it to the subject table. So hence your subject table will become this. So now my first table is already in my second normal form. Why? Because subject ID is there, and it is not, any other column is not creating the partial dependency, because only one column is here in the primary key. Here student ID and subject ID. Now student ID and subject ID are both needed to derive the marks, and student ID and subject ID are both needed to derive the score ID. So everything is fine now. Both the tables are fine now. So now we can declare that, okay, my table is in the second normal form. So this was all about your second normal form. Now let's discuss about the third normal form. So what is your third normal form? So for third normal form, again, there are two rules. The first rule is that your table should be in the second normal form. And the second rule is that there should be no transitive dependency. Now please read the slide carefully, and then we will discuss this example. Okay, now let me explain you this. So here, this was your original table, right? We are just taking the old example. So this was your score table, score ID, student ID, subject ID, marks. Now let's say after a while, using alter table add column command, let's say you decide to add two new columns. So let's say the two new columns were exam name and total marks. These two new columns you inserted. Now, if you are inserting some column in your database, you also need to check that if this new column is creating any kind of issue. If you are inserting any new columns, you also need to verify this, right? That if it's creating any issue. So let's analyze these two newly added columns one by one. So let's first analyze exam name. So can we say that the exam name is completely depending on the student ID and subject ID? Yes. Why? Because only if you have a student ID and subject ID, then the combination will only tell that, okay, which exam that particular student is giving and which exam, what is the subject. So in bracket it is written here that a non-prime key. What is the non-prime key attribute? Attribute which is not a primary key. Simple. So we can say that a non-prime key attribute is depending on the primary key. So this is the expected case. Every column should depend on the primary key, right? So this is the valid case. So our exam name is fine, because a non-prime key attribute, an attribute which is not a primary key, is depending on the primary key. So this is fine. But the issue here is, let's understand the second example. It is written here that the total marks is depending on the exam marks. Why the total marks is depending on the exam marks? Because when you will be having the marks, you will total the marks and then you will calculate the total marks. So can we say that the total marks is depending on the exam marks? So in bracket it is written here that the non-prime key attribute is depending on the other non-prime key attribute. Neither total marks is the primary key and neither exam marks is the primary key. So here it is written, that is why that a non-prime key attribute is depending on the other non-prime key attribute. But this is not expected, since I told you in the very beginning that all the columns, all the attributes should depend on the primary key. But here, total marks is depending on the non-primary key attribute. And when the non-prime key attribute is depending on the other non-prime key attribute, so this type of dependency is known as the transitive dependency. Now, let's understand how can we solve this problem. So here, which column was creating the issue? Total marks. So what we did was, we created a new exam table in which we have exam ID, exam name, and the total marks. So basically, we remove the total marks from this table and we are making a small table, new exam table, where we are having exam ID, exam name, and total marks. So now this makes our data into third normal form.
So this completes our topic of normalization.
So in SQL also, we have a concept that is very similar to functions, and that is known as stored procedure. So let's go through this. So in SQL, a stored procedure is a prepared SQL code that we can save so the code can be reused over and over again. Okay, so just like functions in SQL, it is known as stored procedure. So that is a prepared SQL code. You can save it once and it can be reused over and over again just by calling it. So if we have a SQL query that we write over and over again, save it as a stored procedure, and then just call it to execute it. You can also pass parameters to a stored procedure so that the stored procedure can act based on the parameter value that is passed. So the functionality is exactly the same, just like the functions in programming. Now, just forget about the syntax that I will be showing you. Now, first learn about the benefits of stored procedure. So stored procedure provides some crucial benefits, which are first, that it is reusable, as one of you mentioned, that multiple users and applications can easily use and reuse stored procedures by merely calling it. So whenever you are storing function, so you are basically storing for all of your teammates also, right? It's just not on your local machine. You are basically, since working on cloud, so anyone can use it. So multiple users and applications can use that same piece of code again and again. Next is easy to modify. So you can quickly change the statements in a stored procedure as and when you want to with the help of alter table command. So you can also modify a stored procedure depending upon your use case. Now, security. Stored procedure allows you to enhance the security of an application or a database by restricting the users from direct access to the table. With the help of stored procedure, we are actually hiding the underlying code, the underlying table, and the underlying columns. Now, the fourth point is low network traffic. That is your server basically where your database is hosted. So your server will only pass the procedure name instead of the whole query. So reduce the network traffic. So let's say you have 200 lines of SQL code. Now, if you want to pass this big code, you don't have to pass the 200 lines. All you can do is pass the function name. So it will basically reduce your network traffic. Okay. So let's move forward. We have increases performance. So upon the first use, a plan for the stored procedure is created and stored in the buffer pool for quick execution for the next time. So that means just like your functions and programming, it basically saves your time. You don't have to write your long queries again and again.
Now let's discuss about this new topic, that is ER model. ER model stands for Entity Relationship Model. What is entity, what is relationship, and what is a model, that I will explain you in a while. Before starting this topic, let me ask you one very logical question. Let's say you are working for a company. You are dealing with different databases. You are dealing with different data types and all. Now let's say your friend comes in or a new employee joins in. Now, if you want to explain to that person that what is the data that you are actually dealing with, like what are the tables, what are the columns, what are the different data types, how the two tables or two or more tables are related to each other. So what is the easiest method you can explain to him? Let's say for an e-commerce company, let's say you're working for an e-commerce company. So there are 8 to 10 tables are there. And let's say you want to show to that person what tables are you are having and what columns you are having and how the tables are related to each other. So what is the easiest way in which you can explain to him? It's a very general question. Yes, by showing pictures or diagrams. So the easiest method is you can use a pen and paper, or maybe you can use your computer and you can draw some diagrams. So in the diagrams, let's say you draw some block diagrams, and there you can show that, okay, we have 5, 6 tables, and you just draw a few lines to make sure that how they're related to each other. So that will be the easiest method, right? So that's what is about ER model. Okay. So ER model is basically the representation. The model means your diagrams. Okay. So it is a representation of diagrams. So ER model basically helps you to give you a guidelines to how to draw the diagram and how to show the tables and how to show the relationships between them. So that is all about ER model. So let's learn about the ER model in detail. So ER model defines the conceptual view of a database. Like what is your database? What are the tables present in it? What are the columns present in it? What are the types of columns? Different categories in which we can organize our columns. So that is also there. And how are the tables related to each other? That means the relationship. What is the relationship among them? And so on and so forth. So that is your conceptual view of your database. So it works around real world entities and the associations among them. At view level, the ER model is considered a good option for designing database. Now, this is a general representation of how your ER model looks like. By seeing this model, let's infer what are the things that we can easily understand. Okay, before I begin, entities are your actual tables. So by looking into this diagram, see how simple is it to read this diagram. How many tables can you see? Tables or entities? How many entities are there? Two. That is student table and the course table. Now, if you can see the branches here, this one, and this one. So what are these? These are your attributes. That is your columns in your table. So student ID, student name, and student age. These are your attributes. Similarly, in the course table, you have the following two attributes, that is course ID and course name. So three attributes belong to the student table and two attributes belong to your course table. Now let's discuss about this diamond shape structure in between the two tables, which is linking the two tables. So that is your relationship, the relationship between the two tables. So what is the name of your relationship? Study. So that means student study course. So that's the relationship between the two entities. So here are a couple of terms which we learned here. One is this entities. So entities are basically nothing but your tables. Then we have attributes and then we have relationship. So that is why the model is known as entities relationship model. So let's discuss about this topic in more detail. Okay, let's first discuss about this entity. So what is your entity? Entity are your basically your tables. So entities are represented by means of rectangles. So if you see this ER model, they are represented by rectangles. Attributes are represented by ovals or ellipses, and the relationship is represented by a diamond or a kite-like structure. So entities are represented by means of rectangle, and rectangles are named within the entity set they represent. So if you have the student, teacher, and your project's entity, then all will be mentioned within the rectangle. Now let's discuss about attributes. So attributes are nothing but the properties of entities. So in simple terms, attributes are your columns. So they basically describe the properties of entities. So attributes are represented by the means of ellipses, and every ellipse represents one attribute and is directly connected to its entity. So here you can see that it is directly connected to the entity, just like your student table. So in student table, we have roll number, name, and birth date. So they are directly linked with the entity. And let's say if the attributes are composite means combined. So they are further divided into a tree-like structure. So let's say this is your name. So name is comprised of two more attributes, that is first name and last name. So that is why the branch is cut out from this particular attribute, the first name and last name. So by looking into the student table, we can clearly see that there are three attributes, but name is a composite attribute. So hence first name and last name are the subparts of it. Now let's discuss about the different types of attributes. Okay, so we have simple attributes, composite attributes, multi-valued attributes, and derived attributes. So let's discuss about them one by one. They are also very easy to understand. Simple attributes are nothing but your attributes. Just they don't have any branches or any types of anything. Next, we have the composite attributes that we already studied. So that is your name attribute. So first name and last name are the parts of it. The new ones are multi-valued and derived. Multi-valued, as the name suggests, more than one value. Now, if you see the third figure given here, so what is the multi-valued attribute here? Can you identify what is the multi-valued attribute here? Phone number. That is correct. And why is phone number declared as a multi-valued attribute? Because a student can have more than one phone number. Hence, phone number is declared as the multi-valued attribute. And what is the representation of multi-valued attribute? Double ellipses. So by seeing the different attributes, you can clearly identify that, okay, phone number will be having more than one values. Now let's discuss about this derived attributes. So let me first give you the meaning of derived attribute. Derived means which can be derived using any other attribute. So here, let's say age is your derived attribute. But tell me why age is known as the derived attribute. From which column can you derive the age? So in SQL, we have the function current date. So when you run that function, you get the current date. So all you have to do is subtract current date minus birth date, and you will get the age. So age is known as the derived attribute. And what is the representation of derived attribute? It is shown in the dotted ellipse. So let's move forward. Let's now discuss about relationships. So relationships, as I said you earlier, that are represented by the diamond shaped box, and the name of the relationship is written inside the diamond box, and all the entities, that is the rectangles, participating in a relationship are connected to it by a line. So let me show you the diagram once more. So here you can see what is the relationship? Study. So all the tables are connected to this relationship, and this relationship defines the relation between the two tables. So here study is the relation. Now let's discuss about relationship and cardinality. So cardinality is an important topic. So cardinality represents the number of times an entity of an entity set participates in a relationship set, or we can say that the cardinality of a relationship is the number of tuples in a relationship. So in simple words, the number of rows that are involved in a relationship can be defined as the cardinality. So cardinality is nothing but your ratio. So with example, it will be more clear. So we have different types of cardinalities between the tables. It can be one to one, one to many to one, and many to many. So let me just give you an example of it. So let's say there are two tables, employee and department. So let's discuss about the first example. So the first relationship is your manage. And if you can see in small letters, it is given here 1:1. So what does this mean? You can read it like one employee manages one department, or one department is managed by one employee. So if you talk about the number of rows, if you talk about their ratio, so that is 1:1. So hence the cardinality is 1:1. So by declaring the cardinality, you can clearly say that, okay, it gives you better information about how the tables are related. So you can say that, okay, one employee manages one department and one department is managed by one employee. Now let's discuss the second example. The second example is of one to many. So it's written here, publisher supplies book. So there are two tables, the publishers table, in which we have the list of all the publishers, and then we have the book table, in which we have the list of all the books. So that means it's written here, one publisher supplies n books, or n books are supplied by one publisher. Similarly, we have the case of many to one. That means we have n:1. So that is book has one section has n books, like that. And then we have many to many, that is m courses are enrolled by n students, or n students are enrolled in m courses. So that's basically all about your relationship and cardinality. So it tells you that how many rows are involved. In this session, we are going to understand about case in SQL. Now, let me just give you an overview. So although I will be showing you the complete query, but let me just give you a high level overview. So your case statement looks like this. So here, just like when we were declaring the functions yesterday, you have your end, begin and end. Similarly here, you have case and then end. So it's very easy to understand, but the important part is just read the select statement. What is the first column in select statement? Order ID. What is the second column? Quantity. But what is the third column? Third column is actually your switch case, which is alias as quantity text. So this is basically, that's why in SQL it is important that you write in such a way that your readability is improved. So it's like this. So this is your basically quantity text. The important point is this, that this writing of case, so this quantity text is your column. It is your actual column. So basically you are writing like this, and then you are using alias, and alias is quantity text. So let's understand what is our case. So my case is that whenever my quantity is greater than 150, then you will output this. Whenever my quantity is equal to 150, then you will output this. Else, whatever be the case, you will output the quantity under 150. So let me just show you by running it. So first we will create the table. That's just a dummy table. So what are the columns here? Order ID, quantity, and price. Order, these all are of integer data types, and this is my constraint that order ID is my primary key. So we have declared order ID as the primary key here, and it should be auto increment. Order ID should be auto increment. Let me show you. Have I discussed this auto increment previously? Let me just explain you this. First, let me just create this table. I have created this table. Now let's see that select star from case examples. Okay, so it's empty set. So my table has been successfully created. Now let me just insert one record here. Let me just paste it here. So first let's see what is written here. So here it says insert into case examples, that is my table, and the columns are this quantity and price. And what do we want to insert? We want to insert this value. We want to insert this value. So a random value will be multiplied by actually 200, right? And any random value will be multiplied again by 200, and then we are taking the floor of it. So let's just insert it. Let's just insert it. But to mind you, just see here. So here I had 3 columns: order ID, quantity, and price. But I'm inserting only 2 values: quantity and price. Why? Because my order ID is my primary key and it is auto increment. So let me show you what I mean by auto increment. So let me just paste it here. Now when I run this, select star, so you can see that my order ID is auto incremented from 0 to 1. I don't have to declare order ID every time. So whenever I'm inserting any new record, this order ID will be auto increment. It's in the auto increment mode. Hence it will be 1, 2, 3, 4, 5, 6, and so on and so forth. So in this way, so there are 2-3 observations here. So my observations are: first observation, that you can see that the random value is always between 100 and 200, 100 inclusive, 200 exclusive. Okay, and the order ID here is on auto increment mode. That is, we don't have to update the order ID again and again. It is auto incremented. Even if I insert the next rows, then also you can see, if I do it like this, select star from case examples table, you can see that my order ID is again auto incremented. Now let's come back to my switch statement. Okay, there is one more thing which I want to tell you. Now see, this table is very large. Okay, this has increased to 41 rows, but you don't want to do anything, right, by seeing all the rows. That is why it is important that you provide the limit here. Let's say limit 5, so it will show you only 5 rows. So it's a good practice to use limit. It will save your memory. Now let's come back to my case statement. So let's say my new column is quantity text. So let me explain you this again. So if your quantity is greater than 150, then the output will be this. If it is equal to 150, your output will be this. And if it is any other case, let's say less than 150, then your output will be this. So let me just run this. Okay. So now you can see here, it has automatically created a new column, quantity text, which we created, and it has done all the manipulations in my data. And needless to say, this case statement has multiple applications. Whenever you want to manipulate your data, it has multiple applications. Let's say if you want to filter out like children who have age less than 18, so you can do that. Let's say if you want to do it like this, you want to declare a comment, you can do that. So this comes in very handy. Okay, let's do some brainstorming. The case statement is in front of you. The case statement is in front of you. And the alter command is also in front of you. So what was my alter command? Alter table and this case examples, etc., etc. Now we saw here that if you are running this command, after this command, so my new column, that is quantity text, is not being inserted, because let's say add column. Let's say my column was quantity text, but my data was not being inserted. But if I want to insert the data, what should I do in this case? What can be the manipulation? What can we do here? So let's do some brainstorming here. What can we do here in this case? We can do it like this way. Let's say if we use the update statement. So what is my update? Update is my case examples. And then we will use set. For set, we use column. So let's say my column is, because I've already inserted the column quantity text, so I will use like this, quantity text. But what should be the value in this quantity text? Can we just copy paste it here? Let's say like this. Does this seem logical? Here we have used update and then set, and then we have basically inserted our column into this. We also have some mathematical functions that you must have definitely heard, like the pi function, the pi. So it gives the value as 3.14. Let me just run it. So it's giving the value up to 6-7 decimal places. If you want to calculate the area of circle, so that is pi r square. So that can also be done like this. If you want to do some power function, that is 3 raised to the power 4. So that is done by this function. If you want to use sine, cos, tan, that can also be done like this. And if you want to run any square root, then that can also be done like this. Clear? These are few mathematical functions
And that also comes in very handy, especially at times when we are dealing with statistics or mathematical operations. So this completes our topic of case. So let's learn about subqueries with the proper example. Let's select any other table using this show tables command. Show tables. We have these tables. Okay. So there is a very popular interview question. Okay. You can also note it down somewhere. It's a high chance that you can get a question similar to that. So let's say if I have this select. Okay. And this will be a proper brainstorming. Fine, but I think we can get a better table. Yeah, this is fine. Bonus amount. So first, easy question first. Give me the query to select the maximum bonus amount from the table quickly. So my salary will be select maximum bonus amount as max bonus from bonus table. So it is giving me the maximum bonus amount that is present in my table. If this is my question, this is my query to give me the maximum bonus amount from table. What will be the second, or instead of max, let's keep it highest bonus amount from table. Now what will be the second highest bonus amount from table? What will be the answer? 4,500. Now let's build upon how can we get this answer as 4,500. That's a very important interview question. So how can you get the second highest salary? So here in SQL, we have a concept that is subquery. That's one of the most important topics as far as your interviews are concerned. Subquery. So that means a query inside a query. First, I will tell you the answer. Let me just copy paste this only. Now, instead of this, let's write a proper name and highest bonus, second highest bonus. Okay, select max bonus amount as second highest bonus from my bonus table. That will also remain same, where bonus amount is less than maximum bonus amount from bonus table. And since this is a subquery, we can place it in parentheses to make it more readable. So this will be your query. The concept of subquery is this, that first, what is subquery? Subquery is your query. This is your query inside the other query. So this query is inside this query. So this will be your subquery. This highlighted part will be a subquery. First thing. Second thing, whenever you have subqueries, the concept is that first this part will be executed and then this part will be executed. First the inner query gets executed and then the outer query. The concept is like this. So 5,000 will be my answer because we have just verified it a while ago. What I'm doing here is I'm selecting the salary which is just less than the maximum salary. I'm just selecting the bonus amount which is just less than my maximum amount. So if I see the table here, what is the amount which is just less than 5,000? Even if we have duplicates, this will also work fine. Okay, so what will be the bonus amount which is just less than 5,000? 4,500, because less than 5,000 is 4,500. Okay, so I will get here the answer as 4,500. But before this, let me just show you different types of outputs. So let's break this query into few parts. So first I'm doing this. So I'm getting 5,000. Now, instead of maximum bonus amount, let's do this. Let's run this. If we are not selecting max, then what will happen? I forgot the semicolon. Yes, that's right. So I was giving the issue. You have error in your SQL because of this. Very strange. Yeah. So you see that when I'm not using the maximum function, it is giving me all the salaries which are less than 5,000. Previously, we had 5 records, 1, 2, 3, 4, and 5 records. Now we are having only 4 records and 5,000 is not there. Why? Because it is giving me the output of the bonuses which are just less than 5,000. This is the first part. Is it clear? Now, out of these outputs, what we have to do? We have to select the maximum from them. Okay, that's why we are doing it this way. That select maximum from this. So when I run this, again, I think it's not picking up this arrows. So got it? So if you are running this query, let me write it first because we ran it first. Yeah. So when you are running this query, this inner query will return 5000, and this query will return, this outer query, that means the complete query, or you can say the complete query will return all the values which are less than 5000. But now if you run this command, select maximum of bonus amount, okay, so it will select the maximum amount of these values, and then it will output 4500. Now I also don't know about the third highest salary, but surely we can work together and build it. So let's say first I will run select maximum salary. And just to mind you, just to give you a heads up, as soon as we increases the number of levels of subqueries, your query becomes complex. Select maximum bonus amount from my bonus table. Now if I write from bonus table, where bonus amount, it should be less than, this is my first inner subquery. Subquery is always inner, so this is my first subquery. So it will be select maximum of bonus amount from bonus. Now let's increase the level of subquery from bonus. Let's again write the where condition here, where bonus amount not in from this. Yeah, ideally this should work. Let me just test it out as well. There is some error here. Let me just debug the error. Yeah, so this is my formatted query. Let me just try and running it. Yeah, it worked. It was just a formatting issue. Okay, so this query worked. Now it is giving me the answer as 4000. Let me just verify it also. So select star from bonus. Okay, so 5000, 4500, and then 4000. So please go through this query once. This is the two levels of inner query, and you can see the complexity has increased. So according to the logic, the innermost query will run first, then the outer query, and then the outermost query. There is also a very better way to do it, and that's the most ideal way ideally, and that is done using the rank function. So what happens here is, let me just show you. If this is your data, okay, then what it will do, it will basically create a new column that is rank, and it will give the values for all the rows depending upon your use case. Okay, so let's say 5000 gets the value as 1, and then 4500 as 2, then 4000 as 3, 3500 as 4, and 3000 as 5. And then if you want to select the highest salary, you do rank is equal to 1, second highest salary, rank is equal to 2, third highest salary, rank is equal to 3, and so on and so forth. So that's the most ideal way to do it. This concept of rank is very easy once you have understood it, and it also solves most of the advanced problems. But for now, let's study this inner query only. So first, we have this delete operation, and then we have this truncate operation. So delete operation is used to remove specific rows from table depending upon where condition, but truncate is used to remove all the rows, and that is why where condition can't be used. Where can't be used with truncate. If we are using delete without where condition, then also it will remove all the records. Then why we are using truncate instead of delete? The only reason why we use truncate, that it is relatively very faster than the delete operation. Because let's say if you decide to delete 1 million records, so truncate will be much faster but delete will take minutes and hours to delete. That's a very basic interview question that is being asked, that what's the difference between delete and truncate. So you can answer it. Also, in both the cases, there is one similarity, that your table is not deleted. Only the records are deleted. Even if you do select star from table, then you will get empty set, because no records will be present, but it won't give any error because your table still exists. So these are some of your practice questions. So let's say if you want to drop the table completely, you use the drop table command. If you want to delete some records, you do it like this: delete from this table, where condition you can use. So whenever id is less than 1001, it will delete all the records. And you can also drop your database like this, that drop database if exists, delete. So this type of creating the database, it's very useful. Why? Because let's say you are creating a database, okay, and you don't know that whether the same database exists or not. So you can use this command if exist. So if it exists, then only it will delete. This auto increment I already told you. And this truncate command is like this: truncate table and the table name. Just like you have drop table name, similarly you have truncate table name. Okay, that's it. Let's see some practical implementation. So here are a couple of examples. We will be going through all of them. Let me just copy one of them and show you a simplified example, and then we will go into deeper ones. So just a minute. Yeah, this easy example is fine. Kindly read what is written here. So let's say employee data, and here let's say I write select start from employees. Now my code is fine. Yes, please read this piece of code and then I will explain you. So here first term is your delimiter. So what can be your delimiter? So delimiter is anything, let's say your this semicolon, this is also your delimiter. Okay, now in this delimiter can be any number of characters. So right now I'm declaring delimiter as $sign. So what it does mean is you create a procedure. Procedure is your stored function. So you create your procedure and then you end your procedure with your delimiter. So first you are declaring your delimiter and then you are ending your procedure with your delimiter, which you customized for yourself. And then you are terminating the complete function with delimiter semicolon. That means you are again declaring delimiter as semicolon. Now inside the function, what happens? So just like you have your create database, create table command, similarly you have your create procedure command. Okay, so you create your procedure and then you write begin and end, and in between you write your SQL query. And if you want to call this function, all you have to do is just use this call function. So you write call get employee data, and that's it. Okay, now let me just try and running it. Let me just clear the screen. So I ran this function. It says query okay. It took 0.01 seconds. It's basically your this command. Okay, now let me just call this function. So instead of writing select star from employees again and again, let's just do it call get employee data, and you are getting all the details. So similarly, you can write anything in place of select statement. Let's run out a couple of examples. So here, let's study one by one. So let's say you can create your procedure. Let's say drop procedure. You can also drop your procedure just like you can create it. So if exist, select all columns, use this. So this is your basically table name, and you can basically select star and then you can drop your procedure. You can also create your procedure like this, just like I showed you. So here you are basically specifying the parameter. So let's say if you are providing your table name, and if that table name exists, so it will select all the column, that is select star from the table name which you have provided. So let's say you have your orders table. So you have orders table, or you are passing your orders in your select all columns function. So this is your select all columns function. So this is being called and the parameter is being passed as orders. Now inside it, what will happen? You are declaring the in. In means that it is used for when the parameters are passed. So it works like this. In orders, on what is the data type of orders? Varchar. So that way. So in orders or customers anything, then what is this? You are basically using set. So whenever we are using parameters in stored procedure, so we use set and then you write @SQL. @SQL is basically your any variable name. So @SQL, and you are basically concatenating select star from, this is your string one, and then comma string 2 is your table name. So whatever table name you are passing, here we are passing orders first. So it will be select start from orders, and then you are concatenating semicolon also. And then you are writing prepare S1 from @SQL, and then you are executing it. So it will run the complete function. Similarly, you can drop your database also with the help of your stored procedure. And in this example, I already told you that you can basically create your procedure, let's say for different simple command, that is select star from table. And here you can also use like this. Let's say you want to get any student information. Okay, so you can write select star from student marks, where student ID is equal to student ID. Student ID is basically your parameter. So your parameter will be inside in student ID, and you are declaring the data type of your student ID as integer. So you will pass it. So let's say you call this store procedure tutorial, get details by student name. You are passing one will be inside this, and then inside this, so select star from student marks where student ID is equal to 1. So this will be your input parameters. So in this way, you can explore your stored procedure thing, and then you can apply multiple operations here. Next, we also have your function. So that function is nothing but your delimiter only, but you can use functions also like this. So let's say you can create your function. So let's say function get full employee name, just like you create your table with the column name and the varchar, and you can basically return it like this also.
Let's go through this example. So here we have created a table people. In this table, let's analyze what is being done here. So here we have created a table people, name, birth date, birth time, and a additional column birth dt, just like date time it is given here. Birth date, birth time, and birth dt, that is date time. So if you go through the data types of it, if you go through the data types, all these data types are already covered.
So we have this varchar that is of size 100. We have date, we have time, and we have date time. So let's try running this table. Okay, table people already exist. Okay, I think there is already one table. Show tables. People. Yeah, people table is already there. So let's see if we have anything here inside it. Just one record. So surely we can drop it. Drop table people. Okay. Now we don't have any table like people, so we can just run our command. So my table has been created. So if I do select star from people, I will get empty records because right now there are no records present here. Let's try inserting few values. So let's first understand the statement here. So it's written insert into people. We have specified the columns name, birth date, birth time, and birth date, that is the date time. So here this person, here is the birth date, here is the birth time, and here is the complete date time, birth date time. So let me just run this command. Okay. So my data has been inserted. So you can see my inserted data. So here we have name, birth date, birth time, and birth date time. All it is given. Since we are dealing with the date functions, so we are inserting only date time records. Now let's similarly insert another record which is written here. Okay, that is inserted. Now let's insert this also. Okay, although we can insert it into one go also, but I want to show you something. Now see the difference here. These two records inserted were very similar, date, birth time, and birth dt. But now let's understand what is written here. Here it is written name, birth date, birth time, and birth dt. Name is any random name I'm given, toaster. Birth date. Birth date, we have a SQL function as cur date. I just told you, right? How many of you remember? I showed you on documentation. So, and this current time also I showed you, and this now function I also showed you. Let's say I write here select current date. So my output will be like this. Okay. If I write current time, my output will be this current time. And if I write select now, so it will show me my current date time. That is, this is my date and this is my time. Clear? Now I have inserted all these values into my table. So let's see how my table looks like. Select star from people. Okay. So here you can see that it has basically inserted my current date, current time, and the current date time. Got it, everyone? So this adding the date time, like this. Where it is most widely used industry scenario, let's say whenever you are inserting any record, let's say whenever you are inserting any record, and you also want to store the information that at what particular instant that record was inserted into your database. So you can do it like this. Is the use case clear to all of you? That is one of the use case. There are n number of use case. I just gave you one. So let's move on. Now let's say I run this statement. Okay, let's say I run the statement. What's the statement? Select name, birth date, and the day of the birth date. So we are basically selecting name, birth date, and day of the birth date. So can anyone take a rough guess what can be this function day? And in this parenthesis, birth date is given. That means this is given. So what can be this day? Can anyone take a guess before I run the query? It tells the day. It tells the day. What will be the day? Let me just show you. It tells you the day. That is 11, 25, and 18. Clear? So basically what you are doing, you are extracting the day from this complete date. Also, if you want to make it more readable, you can use alias, that is as, let's say you write birth day. Okay, so it's more readable. Clear everyone? Now let's run this command. So here it is name, birth date, and now we have a different function, that is day name. That is what is the name of that day. Let's just run this. So here you can see that if you check on the calendar, it will be validated that on 11th November 1983, day was Friday. Similarly, on 25th December 1943, day was Saturday. Similarly, today, that is 18th January 2023, it is Wednesday. So it's your day name. Now let's try running the other example. Let's say if I run this example. Here it is, select name, birth date, and day of week from the birth date. So it is basically extracting the day of week. So if you check Wednesday, Wednesday is your fourth day. Similarly, Saturday is your seventh day, and Friday is your sixth day of the week. So these are different types of utilities. Let's say if you run this function, so it's basically what's day of the year. So 11th November is basically 315th day of 25th December is 359th day of the year. 18th January is the 18th day of the year. So you just have to pass the column name and use this function, and basically you can get different types of parameters. So depending upon your use case, you can use these. Clear? So let's move forward. Now, let's say, how can we additionally do it? So let's see, what is this query? It says select the name, birth date, time, and then the concat function. What is the concat function? Concat function basically combines different strings. So let's see what is the string that are being combined. So it's month name, space, day, comma, year as full date. So my name of the column will be full date from this table. So this is my complete concat function. Clear everyone? So here we are using this birth date time, and we are extracting month name from it, we are extracting day from it, and we are extracting year from it, and naming the column as full date. Clear? So let's try running this. So let's first see my original table. So my original table looks like this. Select star from people. Okay. Now let's run this command. Just ignore these arrows. These are white spaces. So this is basically your new column which we just created. So this is your full date. So what it did was concatenated four strings. So first was the month name. So you got the month name as November, December, January. Then you extracted the day, that is 11, 25, and 18. And in between this, you added a space. So how can you add a space? Just write inverted quotes and a space in between. Okay, that's a space in between. Next, you extracted the year from the birth date, and finally you renamed the complete column as full date. So you can see that, let's say in your records it was like this, but the end user, you are making it more readable. Also, if you don't want to add the birth date time because it's not much readable, so what you can do here, just exclude it and you're good to go. Okay, so you can see the name and the full date. Clear everyone? Now let's try learning about the date format. So date format is also widely used. So let me show you the usage of it. So this is your basically date format. So here you basically specify the column name and then you use the specifiers. So we have a lot of specifiers given on the documentation page. So let me just show you. If I search here specifiers. Yeah. So here you can see under the date format function, we have a different types of specifiers and the meaning of all of them is also given. So percentage A means abbreviated weekday name, percentage B abbreviated month name, and so on and so forth. So if you use capital H, it's R from 24 hours. If you use small h, it's 12 hours. If you use percentage I, it's 12 hours. And similarly, let's say if you use percentage W, you get the weekday name, and if you use percentage U, you get the week. So we have a different types of specifiers. You don't need to learn all of them. You can anyways go to the documentation and refer to them. So let's say here we are learning about percentage M, percentage D, and percentage Y. So let's see here. So where is my percentage M? So yeah, percentage D is your day of the month with English suffix. Similarly, percentage Y is your year numeric in 4 digits. That is 2023, 2022. And percentage M is this. Yes, month name. So we have used different specifiers. So let's run this. Okay. So if you, let me just run the original, read the original table. So this is my original table. So you can see the birth date, as there are 4 numbers, 4 digits in my year, 2 digits in my month, 2 digits in my day, all separated by hyphens. Now we are basically formatting our date according to our choice. So let's say if I run this like this. Okay. So now you can see that I have basically formatted it. So I told that, okay, I want my month first, and that also percentage M. So I'm getting November. Then I told that, okay, I want percentage D, that is the day with the TH format. So it's giving me 11th. Okay. Then percentage Y, that is 4 digits. And also I placed a comma in between. So I'm getting the comma in between. Let's say if I did like this, if I put a hyphen in between, then I will get hyphen in between. Okay. So in any format, you can basically display your date time or date or anything. Clear everyone? So this date format is widely used. You can also do it like this. Let's say if I run this command. So it is date format. I pass a column that is birth date, and here you can write a custom statement that is born on a percentage W. So what is percentage W? I showed you on the documentation. That is name of the day, weekday. Okay, so it's written Friday, Saturday, and Wednesday, and I have written a personal line myself, and I have specified in the date format, and I will renamed as birthday. So it makes more sense that these persons, the named person was born on these days. Clear? So you can also customize it like this. Now let's study some more examples. So let's say if I run this function. So here what it does is capital percentage M, I told you, that is it gives the name of the month. Small percentage M gives me the actual month in numeric. So 11th month, 12th month, first month, and then we have a slash. So we have the slash. Similarly, we have percentage D, so small d. So it again gives me the numeric. And then we have percentage Y, capital Y. Capital Y is in this 4 digits. Then at percentage H, that is hour, and colon percentage I is my time. Also, if you do it like this, let's say I do percentage Y, that is small y. So I will get in 2-digit year. So that's from the documentation only. So percentage capital Y is your 4 digits and percentage small y is your 2 digits. Clear everyone? You can also do it like this. Let's say if you run the statement like this. Okay. So what it is basically, a date difference is basically subtracting your current day minus the birth date. So it is basically how many days are between this. So that is that thing. So let's say if today was 18th January, so subtraction is 0. So hence it is there. So that's your date difference. So in this way, you can also calculate the age. That is the current year minus the birth year. So you will get the age. That is the calculated column example. Now let's see this date add function also. This date add function. So if I run this, so what it is doing, it is basically adding, it is taking my first parameter as birth date column. So this is my birth date column. Now this is the syntax that add interval 1 month. So that is adding 1 month interval to my birth date, and the column name is add 1 month. So initially it was 1983 11/11. Now it is 1983 12/11. 1943 12/25. Now it is 1944 01. Year has changed after December, and so on and so forth. Similarly, let's try some new example. Similarly, we can subtract 1 month, we can add 15 months and 10 hours, like the complete interval you can add, and so on and so forth. Basically, you can add different, you can use different types of date functions, play around with them, and use it according to your use case and your choice. Now, let me give you a glimpse of real example. Let's say, how many of you have heard about this Twitter? Twitter, you must have heard about, right? Let's say we are creating a very small dummy table for the tweets. So all of the tweets which are being posted on Twitter, they must be recorded somewhere in the database, right? So in this tweets table, our first table is the content table, like what is the content. So here varchar is 140. Then we have the username where the varchar is 20. And finally, we have a new column that is created at, that is when the tweet was created. And here the data type is timestamp. And here we have also put one constraint, and that constraint is that whenever any new record is inserted into this created at in this tweets table, so the default value should be now. Clear, everyone? So let me just run it also. So I created this table. Whenever I'm inserting any new tweet, so it will check the content, it will check the username, but by default, it will store the current timestamp value now here. So let me just insert a record. So let's say this is my record. So any content, this is my first tweet, and this is my username. So here I'm just inserting this. Just to let you know, I'm not inserting the created at command. So if I run this, so it's inserted. See my record. Select star from tweets. So you can see that there is no use, there is no like need of inserting the current timestamp. It is automatically inserted. See how useful this function is. So you just inserted the content and the username, and it automatically inserted the timestamp. So it helps us to track that at what date time the tweet was made. Here, everyone, let's insert another record with the same username. So now you can see that it's the updated date time. Clear, everyone?
Now, let's do some of the interview preparation. In interviews, it's not that you are being given a complete table in which you have a lot of data. No, it doesn't happen in that case. There might be a possibility that the interviewer is giving you 2-3 rows, just a dummy data, but he won't be showing you the complete table. Instead, he will be showing you the schema of your table. And what does schema include? Only your table name, column name, and your data type. So he will be asking you a question, and then you have to write the SQL query for that question. So this is the basic format of your interviews in which your interviews are being taken. Clear, everyone? Now, let's say this is my employees table. This is my employees table. My question to all of you is give SQL query to give first names of all the employees and rename the column in result as employee name. This is my question. Very simple query that you need to give me the first names of all the employees, and also the first name column should be renamed as employee name. So the query will be select first name, and then since I told you that your first name column should be your employee name, so you will write it as employee name. So this is your output. Now my second question is, let's say I want to convert all of these names into uppercase. I want to convert all of these names into uppercase. So do you guys have any idea about uppercase and lowercase? So let me tell you, it's a very easy function. All you have to do is just write upper and then you close the bracket. So now when you have done this, all your names will be converted into uppercase. Here, my operation is selecting the first name, converting my first name into uppercase, and then renaming this complete as employee name. Let me show you what will happen if I don't write as employee name. Then the formula will be shown here. Similarly, we have your lower to convert all your values into lowercase. So here we have upper and lower to convert your values into uppercase and lowercase. Now, very simple question. Let's say you want to print the unique department IDs. What will be your SQL query? If you want to print the unique department IDs, so the command is very simple. You have to write select. We have the distinct keyword, distinct department ID from employees. So that will give you the unique department IDs in your table. Now, let me teach you about this new function, substring function, which I was just discussing a while ago. So the substring function, as the name suggests, is used to extract the number of characters from your string. Now let's say you have your first name here. Now let's say I want to print the first 3 characters from my first name, or let's keep it to first 2 characters. So what I will do, I will write my query as select. We have a substring function. So let me show you the syntax of substring function. It's very simple. So substring function basically takes the column as an input. So we will write here first name. Then it will ask me from where should we start. So we are starting from the first character, and then how many number of characters you want to extract. I want to extract 2 characters. Okay. And I will close this parenthesis. That's it from my employees table. So here you can see that this is my substring function. I have given the first parameter as first name. Then we have from where you would like to start, and then how many characters you want to extract. Let's say if I start from the second character and the number of characters I want to extract is 2, then your output will be like this. So we also have a length function in MySQL. So let's say you want to calculate the length of every first name. So what you can do, you will write here select first name, comma, length. Length is your length function, and the parameter we will pass first name from my employees table. So it will basically give you the length of your first name. Is it clear, everyone? Length function and substring function. So let's say you want to modify the name of the any employee. So let's take an example. John S is given here. Let's say instead of John S, I want John A. That is, I want to update, not update exactly. I want to replace the value from S to A. So what I can do, we have a replace function in that case. So let me show you that. So we write select, then we write replace. So there are certain parameters here. So first you provide the column name. So what will be my column name? First name. Next, we provide the letter which we want to replace, that is S, and then we provide the letter with which we want to replace, that is A. Where condition we need to provide. Otherwise, it will replace all of it. So we will write where employee number is equal to 1002 from employees. Select from employees. This. So now we have basically used this function, and then we have replaced John S with John A. So we are not actually updating the table. It's just for your results. Your actual table is still the same. If you actually want to update in the table, you have to use the update command. Here we are with the select statement, you just output it. So let's move forward. Now, let's say you have your first name and last name. And now in your output, you want to make a new column. Let's say employee number and the full name. So what will you do here? You will write, we have a concat function in MySQL for that. So let me show you the usage of that. Select employee number, and comma concat function. So concat function will take the inputs as first name, and then we will add a space in between. So we have added a space in between, and then last name from employees table. We actually have to add the space. Clear, everyone? So concat function basically takes any number of inputs as strings. So it is taking first name, and then we will add a space in between them, and then last name. If we are not adding the space, you will get the output like this. To make it more readable, let's use alias here. So we'll write as full name. So we have hidden the function name. We are making it more readable. Now, what is order by? Order by basically means to sort the results. And what do we mean by sorting the results? Either in alphabetical order or whichever number comes first. So if I do it like this, order by, let's say employee number. If I'm not providing anything, by default, it will arrange in the ascending order. And if you're providing descending, then it will arrange in the descending order. So you can see employee number is arranged in the descending order. So this is just for ordering. This is just for sorting. Now, if we talk about group by is a different thing. How is it different? Tell me that, can we make a group of these 3 rows based on the department ID? Similarly, we can make a group of them. Let's say if I want to get the count of all the people in the employees table, what should be my SQL query? So it is basically what it is doing. It is basically grouping all the rows and counting them. I want to get the count of people in every department. So for operations like these, where you are grouping the rows and then applying the function, there the group by function comes in to picture. So let me show you the query. You need department ID, and then you need the count of, let's see, you write here count star only from. So now
So group by 500, 501, 503, 504, and then it is doing the count star. There is one more thing, that whichever column you are mentioning with the group by statement, you have to mention it in the select statement. Group by and order by are completely different. Order by is just used to sort the results. Group by basically actually groups your rows. Now, can you use the where clause here? The answer is no. Where clause can't be used with the group by statement. This is a rule. Department ID is equal to 500. Okay, then it won't work. So there is a substitute for it, and that is the having clause. It works exactly the same, but it's just that we can't use where clause with this group by. So here you will write like this, where having department ID is equal to 500. Similarly, you can use like this. Let's say you are using the in operator. So in operator, you have basically specified two values. So it will match these two values and give the output. So this is your script. So around 115 lines of script is it. We'll just break it down and study the complete flow of like how can you connect with MySQL using some connectors and all. So this will be the primary topic that we will be touching. So first, there are the module that you need to import your MySQL module. So if I show you here, you can install MySQL. So if you just go here, you will go to the official documentation. So there you have pip install MySQL Python. Just copy it and run it in the terminal, and you will be able to install this module. Very simple. And from this MySQL connector, we are importing this another module that is error code. These are your local variables, but let's just ignore them for a minute. So the first part is, first you need to connect to your MySQL server. Okay, first you need to connect to your MySQL server. How can you connect? So in your MySQL module, you have a connector. So you will use a function connector.connect, and in this you need to provide the username, password, and your host. So what is your username, password, and your host? The one which you were using while installing MySQL. Also, like there are a few commands. Let's say if you run on your MySQL terminal, let's say if you run select user, so you will get your user information. So here, this is my username and this is my host name. So user @host name. So this will be root @localhost. Also, you can run a command like this, show variables, where variable name is equal to port. So this will provide you the port information. So here in my system, I'm working on port number 3306. And if you want to get your complete host name, so you can do it like this, show variables, where variable name is equal to host name. You can also note it down these commands somewhere, or you can see the recorded lecture. There you will get the hostname information like this. So you can use this information for your username, password, and your host. Now, when you have connected this, so first you create a cursor. What is this cursor? So this cursor basically points to your database, and we will use this cursor to do multiple functionalities. Let's see one by one what it is done here. So let me minimize the unnecessary ones. So first, there is a try except block. Just go through this code on your end, and then I will explain every bit of it. So let's say you are running your code. So there you must have seen that localhost :8888. So different services run on different ports. So ports is basically used for communication purpose. So when you run localhost on 8888 port, that means your Jupyter is running on that port. Similarly, when you are running your localhost on this port, that is, on port 3306, that means your MySQL server is running on port 3306. If I'm talking about, let's say, on my system, so yes, in most of the cases, my port will be same, but maybe it will differ in your case, because let's say it depends on the number of services that you are using. But yes, ideally, my MySQL will run on this port. What is it mentioned? 3306. Yes, 3306 only. I hope this line number 78 is clear to all of you. Now, please go through from line number 89 to 99, and then we will discuss it. Now, please go through this create database function once. It says that if your database does not exist, then you will create your database function, and then your database will be created successfully. This will be your output. So that's a complete code from line 89 to 99 that use your database. If it does not exist, create your database. And how are you creating your database? From line number 81. So let's move forward. So now, once you have created your database, or once you have selected your database, what will be your next step? Select the table on which you want to work upon. So the command is for table name in tables. And from where do we get this tables from? So this tables is hard coded. Okay, let me just show you one table. Yeah.
please go through this create table command once if you have forgotten. So what happens here is you create your table, and this is your table dictionary. So table name and the value will be your command. So just like we have your departments table, we have salaries table, we have department employees table, and so on and so forth. So different table, it will be a for loop, and what it will do, it will basically just create your table. And let's say if your table, since I told you that your table name can't be repeated, and if your table is already there, if your table already exists, so it will throw the error that already exists. So let's reiterate the steps, whatever we have discussed so far. So first, you connect your database using your simple connector.connect. So user, password, and your host. And how can you get your user, password, and host? Using these commands like select user. So select user will give your username and your host. And if you run this command, this one, show variables, where variable name is equal to port. So you will get the port value. So just write it here wherever required. Just connect to it, use the database. If database does not exist, create your database and then run the create tables command. Now let's go to line number 114. So line number 114 is like after you have completed your work, you also need to close your connection. So you created your connection in the first step, right? Now you need to close your connections. Clear? So you just write cursor.close and cnx.close. So first you will close this connection and then you will close this. See, whenever you have a doubts like these, just go to this, let's say Python, MySQL documentation. Okay. And there, just go to the dev.mysql.com. Okay. And here you will be having like connector Python installation and coding one. Okay. So here you have this. Let's say I go to this, connecting to this. So see, here you have all the functionalities. So if you want to do a simple connection, just run this import command, just connect to your username, password, host, and database. You can also specify your database here also. There are multiple options. Okay. And just close the connection. So it's just a variable. CNX is just a variable of the function for the connection function. So this is basically about your creating your database and creating your table. Next is if you want to insert your data. So in similar manner, you can do just connect it. Okay, you can also provide the database like I just showed you and just insert the data. So add employee command, add salary command, and just execute it. But there is only one thing different here. So there, after you have done some changes in your branch, you commit your code, right? So here also, after you have pushed your data into the database, you need to save it. That means you need to commit it. While inserting the records, there is only one thing that you need to remember, that after you have inserted, you need to save your changes. So you do cnx.commit that your data is committed to the database, and also you finally you close the connections. So this was about inserting your data. Now let's see about reading the data. Reading the data also, steps are same. First connect to your database, connect to your server, provide the database name, and then write your query command, that is select whatever from your table, where condition, and then you have to just execute it. And after you have executed it, your results will be stored in your cursor function. So just run a for loop that for first name, last name, hire date in cursor, print all the rows. So all your rows will be printed. Now, after this, let's say you want to basically do some operations. Let's say you want to use the update command. So like all of the operations which you have studied up till now, you can do it. Okay. The steps are exactly the same. You just connect it. You can also create multiple connections. Why are we creating multiple connections? Because let's say 2-3 people are working on the same database. So there will be multiple connections, but now you can also test from your terminal. So basically, let's say here we are creating 2 connections, cursor A and cursor B. So what will cursor A do? Cursor A will execute this query. So this query will be executed, and then cursor B will execute the query. So both the queries will be executed simultaneously, and your changes will be made. So here you can see that cursor A executed this query and cursor B executed this query. And after that, you have to commit these changes and then close the connection. So this also you can do, because as I told you earlier, that in MySQL, multiple people can collaborate, multiple people can use the same database. So that you can do, that you can test it on your same Python code, that if you make multiple connections, how it will work around. treat these two connections as two separate people working. There is also one module that is you can basically test your connection also. Why is testing important? Because let's say you created a newly database, or let's say someone else created a database, and before working on it, you need to test your connection. That if your connection is successful, if you are able to connect. This happens a lot of time when you're working with a real data set in the company. So basically you test your connection. So what is the best way to test your connection? Simply run mysql.connector.connect, provide the username and password that your company has provided to you, the host name and the database. And if this command executed successfully, then print connection successful. Else, there can be three different types of errors. Let's say if the error is access denied. When can be the error access denied? Because let's say in the company in which you are working with has not provided you the access. So let's say there are 25 databases in the company, and the company has provided you access to only one of them. You can get the access error, or maybe you might not be having access to any of the database. So then also you will get this access denied error. So it can be wrong with your username or password, or maybe there is some access issue. So you need to contact to your company. They will provide you the access, and then there will be no error. And there can be error code dot error bad db. So bad db you get when your database does not exist. So you can print here database does not exist. If there is any other type of error which might be, then you can print it under the else statement. And after this, when you have done this completely, then also don't forget to close the connection. So in this way, you can test your connection to MySQL through Python.